Cool. Still the last few people coming in, so I want to make a quick note. It's really cool to see your face inside the portal right there. It's really cool. So hello and good morning, everyone. Good to see that so many people are interested in knowing more about the new concurrency model inside Java, the virtual threads and everything. So that's also the topic for today. I'm going to give you an introduction and tell you all about the pitfalls of Java's new concurrency model. My name is David Vlijmings, and I am a software developer in the Netherlands for around 6 or 7 years now at Team Rockstars IT. It's a consultancy company. If after this event you have any questions or want to reach out to me, you can find me on Twitter or multiple ways to contact me through my website, or also some examples that will be shown today. We have some explanation and some diagrams, so it should all be clearly structured. So let's start. And I want to start today's talk with the outline and the current situation of what the current way of concurrency is inside Java. So we will see what is the current threading model we use now, and then slowly see what are the problems with it and how can we improve on that. And then we will slowly go into the virtual threads and how they work behind the scenes, what they do, what they are, and how they work, and how we can create 1 million of them, or 2 million, as we have seen this morning. And then how we can manage them using structured concurrency, because then we have all these threads, and then we want to somehow group them as a single unit of work, and then we can use structured concurrency for. And at the end of the presentation, there's still some time for a Q&A. So before I really start, I want to have a word of caution. It's still a work in progress. The virtual threads, they are not in the mainstream version of Java yet. They are targeted for Java 21, so in September everyone can enjoy them. I don't expect them to change a whole lot anymore from now on, but it's especially the structured concurrency part that is still very much in development. So some methods may change, and some wording, some names, but the whole idea behind them will stay the same. So let's get started. And this is how we create a single thread in Java. Can I get a hand up from everybody who has done something like this before? That's pretty much a lot of people, which is really great. So what happens here is that we call the thread constructor and we ask, can we have a thread that we can use inside our application? So what happens is we make a call to the operating system and ask the operating system, can you create a thread for me that I can use inside my application? And the operating system is like, yeah, I can do that for you, but I will need to reserve some memory for this thread, so let's say around 1 megabyte, and then you will have a thread that you can use inside your application, which is all fine. Then we come back inside our application, and then we have a thread that you can use. So what we can say is that a thread inside Java is just a very thin wrapper around a thread that is managed and scheduled by the operating system. And because of that, and we have virtual threads with Java 21, it gets kind of confusing. What kind of threads is he talking about? Is he talking about the virtual ones or the ones that are managed and scheduled by the operating system? And as you can see hinted in this, the title of the slide, is that it says platform threads. And that is because to tell the difference between them is that we now give them the name, platform threads. So when we talk about threads that are managed and scheduled by the operating system, we are talking about platform threads. And as we will see later, is that virtual threads won't be managed by the operating system, but that's a story for later. So when I come back to the little example code on screen, I have my thread, I call the start on it, and it will start my task, and it will run inside a platform thread. So the ideal way of using this task is done. I will just throw this thread away, and the garbage collector will clean it up for me, which is a really convenient way for us to program our software, but we don't make the best use of our resources, because every time I'm going to create a thread, I have to go to this operating system. Can you create a thread for me? To reserve some memory, which are very expensive operations, and then I have to go back inside my application, and then I can continue. So if I do this every time for each task that I have, it's going to be very time consuming, and I'm not making the best use of the resources that are available to me. So with Java 5, we are encouraged to use the executor services instead. And what they do behind the scene is that they just create a thread pool for us to use. So they do all the work for us. The only thing that we have to do is submit tasks every time we want something to run. So as you can see at the right, I have this small thread pool. It's the blue box with the 3 threads in it. And I submit some tasks to it. So every time I submit a task, a thread that is doing nothing inside the pool will pick up a task and will start running it. But this also has some downsides. Well, and one of them is the thread locals. If I have a task that sets a thread local variable on one of my threads inside the thread pool and forgets to unset it, this thread with this thread local will be put back inside the pool, and another task can pick up this thread will pick up a new task, and this task will be able to see this thread local variable. And at that point, you are leaking your thread local variables into other tasks, which isn't the best way. And of course, blocking waste resources, because when I have a thread inside my pool, and it has a task, for example, to, let's say, make a call to a database or to a web service, while it is making this call, it's waiting. It just blocks and just waiting for something to return, which isn't the best use, because while it's waiting, it could also pick up some new task to run, but it isn't. And then we just have a waste, because then we are blocking this thread, this very expensive resource, with just waiting, which isn't ideal. And then we get into async programming. Async programming tries to solve this by, well, not trying to block really. And for us programmers, it is very hard to, or in my opinion, it's very hard to write. It's harder to read, especially the week or two after you've written it. And it's very hard to debug. But the positive side of it is, it makes very good use of the resources. It makes very good use of the resources that are available to us. So it's good for the computer, but it's a little bit less for the developer. And this is where virtual threads come in. So virtual threads are just an alternative implementation of the thread class, which means that they aren't there to replace the platform threads that we are currently familiar with. We still have those, but we get a new option, and that are the virtual threads. And the virtual threads are just a concept that lives inside the GVM. So the operating system doesn't know anything about them. And the great thing about this is that now the heap, so the memory for this thread now lives in, the stack of this virtual thread now lives inside the heap. So we don't have to reserve some memory for the platform thread that we would otherwise have created. So for a virtual thread, we just create the virtual thread, and it will just give it a little bit, a very small stack to use, and it can just grow as needed. So we can just start out with a very small amount of memory and just grow as we would need to, have for this thread. And combining this, so we don't have to make a call to the operating system, we don't have to allocate a lot of memory. This makes those threads very cheap to create. Well, how cheap do you ask? So I created this little nice diagram. I think it's nice. So using the native memory tracking, I had a simple application that uses 64 megabytes of memory as heap space. And then I just started creating threads. So I just started with a single platform thread and a single virtual one. And it's just very hard to see, but the platform threads still will win. They still use a little less memory than a single virtual thread will use. And why that is, we will see later. But when we go into 10 threads, so we have 10 threads of each, you will still see that the platform threads still use a little bit more memory than the virtual threads do. And then we go into bigger numbers, 100, 1,000, and 10,000, and usually slowly seeing that number rise, and then it doubles, and then well, it really skyrockets into almost 500 megabytes. So these platform threads really start to use a lot of memory when you have a lot of them, while the virtual threads, well, virtually use almost no memory. Or, well, it's still, they grow very little over time until, well, we go from 10,000 to 100,000, and yeah, then it doubles, but the number is 10 times as huge. So you may be wondering, why doesn't he have the 100,000 platform threads? And that's because the, well, system crashed, because it also ran out of memory. So you can either see it as platform threads are very resource friendly at the 100,000 threads, or virtual threads are a lot better. So that's enough of me talking. So let's now switch to the demo and see how we can create virtual threads. So I have here on screen, is it readable? Let's just zoom in a little bit. So on screen I have two runnables, one that prints hello JPrime to the console, and just one sleep task. So now let's just create a single virtual thread. So as I've said before, they are just an alternative implementation, so I can still store them inside a thread, and I'm going to call this thread VT. You still don't see very well. Sorry, too many people. What? Yeah. Settings. Is this better? And bigger. Is this good for everyone? Great. So I have here this thread. I'm going to create a virtual thread, and as I've said before, it's just an alternative implementation, so I can still store it inside a thread. So instead of using the thread constructor, I'm going to use a static builder method called the start virtual thread, which will create a virtual thread for me, and it will start running immediately after calling this method. And I'm going to give it the print task, and I'm going to give the virtual thread a chance to print it to the console by joining it. So this would probably also be a little bit too small. Let's zoom in. And as you can see, it prints a hello JPrime to the console, which is really nice. So we do have now this one static builder method, but we also have a builder, and that I can use the off virtual. And as you can see, it gives me two options, off virtual and off platform. And using the off platform, I will create a platform thread, and using off virtual will of course create a virtual thread. So I will use the off virtual, and I will set, for example, the name. I will call this VT JPrime, and I can give it a unstarted task, which will also be the print task, and call vt.join. But then, because it's an unstarted task, I would have to start it myself. And then when I run this method, you can see it prints JPrime to the console. Nothing really that different from the first example. So as I've said, with Java 5, you are encouraged to use the executor services instead. So with Project Loom and the virtual threads, we also get a new executor service. Let's call this virtual thread executor, just VTE for short. And I have the new virtual thread per task executor. And this virtual thread per task executor, for each task that I submit, it will use a virtual thread to run that task. And as you can see, IntelliJ already gives me a hint. It makes this yellow. And that's because the executors now implement the auto-closable interface, which is really nice, so I don't have to close my executor myself, but I can use it inside a try with resource statement. So let's add that too. Doing something wrong. executed service. Thank you very much. So I have here this executed service, which implements the auto-closable interface. And inside this try, I can create the virtual threads that I want. And when I exit this try, all my virtual threads have to be done running. So let's submit 3 tasks, just 3 times the print task. And start running. And as you can see, it prints hello JPrime 3 times to the console. And I don't have to call the join on each of the threads because I will have, because when I exit this try statement, all my threads have to be done running, which is really nice. So as I've said in the beginning, you can also create a lot of threads. So let's do that now. So using a simple for loop, I can just create, well, as many threads as I want, in this case 10,000. Let's give it the sleep task, otherwise my console isn't going to like it. I run it, it finishes and it created 10,000 threads. So there are no more memory issues when you create a lot of threads, which is really nice because they are so that cheap to use or to create. So how does this work behind the scenes? Because as I've just shown, I have created 10,000 virtual threads, but I ran it on a laptop which only, well, it doesn't have 10,000 cores, so how do these virtual threads run? So how does it work? So here I have a very simple diagram, and I have the virtual threads that I just created at the top, and the carrier threads at the bottom. So my virtual threads don't directly run on the system. They run on what is called a carrier thread. And a carrier thread is just a simple platform thread, but it is designed to run virtual threads. So each of my carrier threads gets assigned a pool of virtual threads it has to run. It uses a fork join pool. So each carrier thread has a pool of virtual threads it has to work through. And because it also has it uses a work stealing scheduler, when a carrier thread is done with its virtual threads, it will just steal a virtual thread from another carrier threads pool. So the best thing about this is that now my carrier threads, which are my very expensive platform threads, are always running. They will continue running, they have always something to do, because there are always virtual threads to run. So how does a carrier thread know when do I switch from one virtual thread to another? And that is done with mounting and unmounting. So here I have my simple carrier thread, and it is running this virtual thread. So it is running happily, everything is nice, life is great. And then it encounters a blocking method. So this could either be a call to a web service, to a database, really anything, just a sleep. And then my virtual thread is blocked. And when it is blocked, it will get unmounted from my carrier thread, which means that the memory this virtual thread uses is being copied back inside the heap, and the new virtual thread will take its place. So my old virtual thread is taken off my carrier thread, and a new virtual thread will be run inside my carrier thread, and my virtual thread that was running is now back in the heap. It's waiting for something to return, to continue. But in the meantime, my carrier thread can just continue, which is really great, because then my very expensive resource is working. But not every method is ready yet. So, for example, if you encounter a synchronized block, a object.wait, or you make a call to native code using GNI or access the file system, at those points in time, your virtual thread is being pinned to the carrier thread. And when it is pinned, it means that it can't be taken off its carrier thread. So then you are still back in the old situation, and it acts and behaves the same like the platform threads. You just have a task, and it's running on its carrier thread. So when you encounter these methods, it won't be unmounted, and another virtual thread can't take its place. And that's where the pitfalls also come in. So, for example, if you have a long-running calculation that never blocks, your virtual thread also will never be taken off your carrier thread. It will be stuck, it will run its calculations, and when it's done, only then it will switch to another virtual thread. Also, pooling virtual threads is a big no-go because you're not supposed to do that. They are so cheap to create that you just have to create them when you need to. So pooling is something you should never do. And something that also some people are doing is using a thread pool as some kind of lock to limit the amount of connections to a database. So as I have said, because virtual threads, that you should never pool them, you should also never use them in some kind of lock situation. And of course, some old libraries may use these unsupported methods, and in those cases you may not get the performance that you may have expected to have. So those are some things you have to watch out for when using virtual threads. So now we have a lot of virtual threads that we can use. So how can I group them and use them as a single unit of work? And that's where structured concurrency comes into place. It helps us manage the lifetimes of the virtual threads that we are creating. And before I dive deep into what structured concurrency really is, I want to start with something that's also structured and we are all familiar with. And that's this very simple Java method. And it's called method A. And it makes two method calls, one to method B and one to method C. And it returns a result from these two methods. And there is this kind of relationship between, well, the parent method and the two child calls that it makes. And you can put it really in some kind of line, where we start with A at the top, then you start doing method B, C, and then you will have a result. And this is really nice because this relationship, it tells you when something happens, when you need to abort, when you don't have to continue anymore. So for example, if method B throws an exception, you know you don't have to call method C anymore. At that point in time, you can just stop. Method C will never run. Method A will also stop, and the caller of method A will know something has happened, and I can act on it or not, but I'm not wasting any more resources, and I can just continue. And the same goes for method C. If method C throws an exception, I have only ran method B, and then at method C I can stop, and well, that is it. So this is a very simple example of the flow of, of structured code. So now let's add some threads into this example and see how things can go wrong. So here I have the same method, but now it's method B and C, they use threading, and I will get my result later. And so they run now concurrently, and when just before exiting method A, I'm going to create a result and return it to the caller. So now I'm going to do the same. What happens if method B throws an exception? So when method B throws an exception, my first method B, well, that thread will clearly be done. It won't run anymore. But then method C, which also has a thread, is still running. So I now have to go fetch it and cancel it myself, which, well, is possible, but it isn't really nice, and it's more code for me to type, and less code is more maintainable. So yeah, it's really great. But the same thing can happen with method C. And with method C, it's also a pity if it fails, but it's a little bit worse, because then I have my method B, which is still running, this thread. And then I will start my method C, it will start running, it will throw an exception at some point. But then my method B, this thread, if it takes 5 minutes, when I do this foo.get, I will have to wait the full time of my thread to finish before I can continue. And only at that time, when I do the bar.get, I will find out, hey, my thread has thrown an exception, I can't create results, so I have wasted a thread, I have wasted my time, while I could just have stopped. So this is the, oh, and of course, if you have the parent thread, if that fails, then I have 2 threads running inside the system, they are leaked, so there is no connection to them. I have to, well, find some way to to cancel them, or else I have to leak 2 threads inside the system until they are done, which also isn't an ideal situation. So let's see how we can do this in code. So let's switch back to the second demo. And let's zoom in a bit. Put this a bit aside. So what I want you to focus is that at this try, I use something that is called a structured task scope. And the structured task scope is what is used inside Java to use structured concurrency. And with Java 21, we get two policies, and those policies will tell you how my threads will behave and when my structured task scope, when this will shut down. So when my threads will be cancelled. So as you can see, I here have the structured task scope at the top. And then I have what is called the shutdown on success, which is one of the two shutdown policies that I have by default, that you'll get for free. And it takes a string as the return type, and then I can use the scope. So the scope is the variable that I can use inside my try statement that I can use to fork new virtual threads. And each of my virtual threads that I will create using the scope object will adhere to my shutdown on success policy. And what the shutdown on success policy states is that I'm only interested in the first thread that finishes. So in the example, I scope two, or using the scope I will fork two new virtual threads. And I'm only interested in the first virtual thread that finishes. So that could either be the virtual thread that returns result 1 or result 2. And then I will do a scope.join. And the scope.join will block. So the parent thread will block at this point. And it will wait for my two virtual threads to be done, or at least the first one to be done. Because that's what my shutdown on success policy states. So when I continue from this join, I can use the scope object, and the scope object has a method called result, and the result method will get the result from the first thread that finishes. I don't have to fetch myself which thread has finished first, I don't have to check it myself, but the scope knows which thread finished first. So when I run this example, and let's zoom in a little bit, you can see that result 2 was the first thread that finishes, and then my result 1 thread will be shut down by the scope if it didn't finish in time, or as the first one. So that is how the shutdown on success policy works. So as I've said, there are two built-in shutdown policies, and the other one is the shutdown on failure. And the shutdown on failure policy states that either all my threads finish successfully, or if one throws an exception, then I'm not longer interested in the result and I can just cancel all of them. And this structured task scope, this works the same. I use a try with user statement, and inside this try I create the threads that I need. And as you can see, I use the scope, I fork two new threads, and both of them return a future. As I've said in the beginning of the presentation, it's still very much a work in progress. And they're still debating over what it is going to be called when it is released. So for now, it's in the current early access build, it is called a future. But this is going to change probably to something of a subtask. It's going to behave the same, but just have some different methods of accessing the value. So again, with the structured task scope, I'm going to have to do a scope.join. The parent thread will, at this point, wait for my threads to finish. And when they are finished, I can continue. But you can also do something like have a deadline. And you can do the join, you can use the join until to set a deadline. So when the threads that I'm going to start are going to have to finish before, well, in this case 10 seconds. So I give them 10 seconds to run. If they don't finish in time, I will just shut them down myself. And I'm no longer interested in the result. And then you can see something interesting. And this is the scope.throwIfFailed. And the throwIfFailed will rethrow the exception that has happened inside the thread that has failed the first, inside the first failed thread. So if one of these would throw an exception, I can rethrow that same exception using the throwIfFailed method. So when I run this example, you can see that it prints result 1 and result 2 to the console. And the great thing about using the shutdown on success structured task scope is that after this join and after this throw if failed, when I go into my print line, at this point in time, at this point in my code, I know that both of my threads, or all the threads that I've started, finished successfully, because otherwise I would not have came to this point in my code, which is really nice. So now you have seen the two built-in shutdown policies, which are fine, but sometimes you need something a little bit more that fits your own project. And then you can create your own structured task scopes. But before I'm going to show that, let's give you a little bit of an introduction. I'm going to create a structured task scope, or I'm going to extend one, that is going to return to me a product that is less than 50 or less than 100. So I've created 3 products. One method call that returns me a product of price 50, but it will wait 50 seconds. I have a product of the price of 300, but I will wait 10 seconds before I can return that result. And then I have a product with a price of 200, which will return immediately. So here I am in my structured task scope. So to create your own structured task scope, you have to extend the structured task scope, and you can say, okay, I want my structured task scope to return a product. So here I have my class, it's called criteria scope, and I use a project volatile, private volatile product to temporarily store the product that has been found. And then I come into my handle complete. And the handle complete method is called by every virtual thread that either finishes successfully or has failed. So you will always get a complete future object as a parameter at the top. So this is really the method that you want to override when you are going to create your own task scope. So the first thing that you will have to do, or I want to do, because I'm only interested in products that are worth less than 100, is to check, did this thread finish successfully? Because I can't have a product if the thread didn't finish. So the first thing I have to do is check what is the state of the virtual thread. So in this case, I'm only interested in virtual threads that have the state success. And then I'm going to check, is the result of my virtual thread, so of my future, less than 100? And if that's the case, I'm going to temporarily store my product, and then I'm going to call the shutdown method. And the shutdown method will shut down all the remaining virtual threads that are still running, because at this point I have found my product that I want to use, and just a simple get method. So here I have, again, a try with resource statement. I create my new criteria scope that's going to return my product if it's less than 100. And then I'm going to use the same fork method that will create a virtual thread. And each of these virtual threads will run their own get product. So I have to get product 50, 300, and 200. and each of them will return a result. And then at the scope.join, my parent thread is going to wait, my method is going to wait for all my virtual threads to finish, because at this point I have either found no products that match my description, or I have found a product that I want to use. So let's see what this prints. So I'm going to run that method. And let's zoom in a little bit. And as you can see, those are the 3 states of my virtual threads. As you can see, both 50 and 300 return a success. So these 2 virtual threads did finish, but I didn't stop when I found my product that's with a price of 200, because it's worth too much. I only have 100, so I can afford it. But when my product 50 finished, at that point I can just shut down my virtual threads, and that's why my product of 300 has failed, because it took too long to run, and I had already found a product that I want to use, so why continue at that point? And that's all you have to know about structured concurrency to start using it. And the pitfalls of structured concurrency really is managing the lifetimes of threads yourself, because with structured concurrency it makes it that easy to let the structured task scopes do it for you. And when you do it your own, there's always a chance that you will introduce new bugs. So my advice would be to really use structured concurrency when you can, because it's a really nice and powerful way to do so. And to summarize, all you need to get started, because I've talked a lot about virtual threads and structured concurrency, are just these 2 methods: the start virtual thread and the new executor service with the new virtual thread per task executor. Those are the 2 methods that you are going to need when you want to start using virtual threads, which I really encourage you to do so, because it's really fun to start playing with them. And I want to thank you for being here. So, are there any questions? There's 1, 2. Oh.
Have you used this in real projects?
No, because it hasn't been, it isn't really available yet. It's still in the preview. But I hope to do so when it's available inside Java 21. So, yes? Yeah? I don't know it by heart, but you can see it in the flight recorder. When you use it, you can see when a virtual thread is pinned. And I think there is also a command line option that you can pass to your program, and then it will also say when threads are pinned, but I don't know it by heart. So. But it is there. There is an option to see if virtual threads are pinned. Yes? Yeah, that's a great question. I don't really know, because I talked to some people at the Helidon project and they said they had an issue with the file system, or they gave me the tip that it was a problem with the file system. It also specified it inside the Java enhancements proposal, the JEP. So I have to also look into it. Maybe that has changed. Maybe they finally fixed it. So, yes?
You said that for file I/O,
Yeah?
the virtual threads are still working, so they don't allow the career thread. But on the previous talk, the cat showed exactly file I/O example with files.lines, and after that it was shown that the career thread was changing. So is it still doing something with file I/O?
It is still doing something, but then from the last time I checked, it was still being pinned to its carrier thread. But I would also have to verify if it's fixed and now it switches threads.
I did see that Bankcard had Java 20, so maybe that was like,
Here, thank
Yes.
you for the talk. My question is related to aspect-oriented programming. Suppose I put transactional notation and I'm using string data GPA. If I'm dealing with regular platform threads, then the transaction status is being binded to the platform thread itself until there is a block in IO code support bounds. But you mentioned that every time a block in IO call occurs, that the thread is being switched to another thread. And if I
Yeah.
suppose that the transaction is binding to the virtual thread, then how am I supposed to deal with the transaction in that case? Or I have to be sure that all virtual threads are being binded to the same platform thread.
Yeah. I don't know how it is supported using the transactional, so I think it really depends on the framework and if they implement it at that point. So, I don't know. It's, I guess it would depend on the framework you're using. Well, if there are no more questions, then thank you for being here.
Okay, hello everyone. It's time for the next session. I would like to introduce you to Tim, our next speaker. Tim is a very experienced senior software engineer and an open rewrite contributor. In fact, this is the topic he's going to talk about. After this session, we will also know how we can migrate, for example, our JPrime IO website from Spring to Quarkus, for example. Yeah, so Tim, you have the word.
Yes, thank you. Hi everyone, and welcome to Major Migrations Made Easy. As said, my name is Tim Tebeek, and I'm a staff software engineer at Modern, where I work on Open Rewrite. I want to thank you all for coming, because it appears we have quite some interest in running major migrations today. But even though this is a presentation on migrations, I'm not going to ask you all to raise your hand to indicate what versions of Java or frameworks you're using. And that's because it's not very representative. If I ask the audience who is using Java 17, then some overconfident folks will raise their hand as soon as they've managed to get one service up and running on Java 17, and then completely ignoring the fact that they've not yet migrated to some of the new language features, and that they've left behind the rest of the company back on Java 8. So instead, since you've all made it here, I think it's safe to say that you're quite likely you're still working with something that you want to get rid of. And if not, you're welcome to silently accuse the person next to you of still using Java 8 or JUnit 4 somewhere, and you'll likely be right. Now, before I switched to Modern, I was a consultant for 5 years, and that's perhaps much like yourselves. I specialized in migration engineering, which is a way of saying I would walk into an organization, familiarize myself with all the old technologies that they were still using, and then gradually hack away at lifting everything up to the latest versions. I would frequently find 5 or even 10-year-old versions of Java, JUnit, and Spring, which is not great from a security perspective, or even for the developer experience. Initially, I would migrate these services by hand and gradually introduce more and more coarse-grained automation. So imagine my excitement when I discovered Open Rewrite. Open Rewrite promises to make light work of all such migrations. I got so excited about its technology that I started to contribute and even present about this at conferences, and eventually quit consulting to work on Open Rewrite full-time. So after a nice sabbatical, that brings us here today. And perhaps you face some of the same challenges that I did. At a conference like this one, you'll hear all that's coming up in the new Java 21 in September, and any new framework releases coming up as well. But then back at work, you're still stuck using Java 8 and JUnit 4. And migrating all of that by hand can seem daunting if it ever gets priority. I want to show you how easy it can be to perform major migrations. That way you too can adopt the latest language and framework features. And it can be fun to adopt new language features such as records and text blocks, but you don't want to adopt these features manually or only on a single project. Instead, we will look into automation to make old projects feel like new projects again, rather than one that's just had its version number changed. That way you can benefit from JVM, language, and framework improvements. Here's a brief overview of the types of migrations I'll be talking about. Likely you've already performed some of these migrations in the past, and other migrations are always just around the corner. And if you look back over time, there's a near constant stream of worthwhile improvements to pick up. And I like the challenge, so I still get excited whenever a new version comes out. I just don't like the repetitive steps that come with updating. And if you try to keep up by hand, you will hardly get anything else done. Especially as microservices these days mean you're not just upgrading once, but dozens of times. Over the years, we've seen countless organizations adopt microservices which tend to look alike. That can be either by consciously using reference templates, or by simply copy and pasting from the last service you worked on for any new development. And this can be great for knowledge sharing or reusing shared components. But when a critical issue arises in your technology stack, suddenly everything's on fire. To react quickly, you need a framework that allows you to make broad sweeping changes safely and at scale. Automation may be the only option, especially for large organizations maintaining thousands of services. Now, to show you just how easy it is to migrate a project, I've prepared a small demo. For this demo, we will upgrade a Spring Pet Clinic branch from Spring Boot 2 on Java 8 all the way to Spring Boot 3 on Java 17. We will look at the commands and changes made in more detail along the way. Now, for this demo, I'm going to take you to the documentation that we have on Open Rewrite. If you only remember one thing from this presentation, let it be docs.openrewrite.org. That's where we have all the instructions on how to run Open Rewrite recipes, what recipes we have available, how to develop your own recipes, and if you get stuck along the way, how to reach us to get help. Now, as I said, we're going to look at a Spring Boot migration. And for that, we're going to switch to that particular recipe. Now, a recipe is a set of rules that we apply to make changes to your project such that you can upgrade you to the latest version. Now, for this particular one, we're going to migrate you to Spring Boot 3. But if you're not a Spring Boot 3 user, there's probably still going to be some changes in here that will be relevant to your project. Because as part of a migration to Spring Boot 3, you're going to have to upgrade to Java 17. And you're also going to have to update, pick up Jakarta instead of the JavaX dependencies. And if we look back at the changes that we make for Java 17, we're not just going to update your compiler settings, but we also pick up some optional changes, such as introducing text blocks and introducing pattern matching for switch. And if you haven't yet upgraded to Java 11, we're going to take you there as well and get you all of the JXB dependencies that you need to add to modernize your application. So we will figure out where you are and apply any changes that you still have to make. So even if you forgot to apply any of these changes manually before, we can still modernize your application with these automations. Now, to run these migrations, it's fairly easy. We have a usage tab, which will show you the instructions for Gradle and Maven. But for Maven, it's even easier if you just run this one command at the root of your project. This will make all of the changes locally on your machine and output the changes into the same file server. Now, in the past, I've run this demo on my machine while on the stage, but it doesn't really look good, and it takes quite some time. So instead, what I'm going to do is I'm going to switch to our platform that we develop at Modern, which allows you to run these same Open Rewrite recipes against your own repositories at scale. So in this case, as you can see, we're going to run the migrate to Spring Boot project against the Spring Pet Clinic, which is a reference implementation of how to use Spring and Spring Boot. This is all the same steps that you've seen before. And in this case, I'm going to do a dry run. So we're going to run all of these migration steps, but we're not yet going to make a commit. Now, in the background, we will load a serialized form of your project such that we can quite easily and quickly run these recipes. And you can see that I'm running this against two different branches of the same project. One is the main branch, which has already been upgraded to Spring Boot 3.1. And I'll show you in a minute why I'm still migrating a project that's already using Spring Boot 3. The other branch is a 2.0.0 branch, which is from 2018. So it's not been updated since, but we're still able to make the required changes to upgrade this to the latest version. And as you can see, we ran this in just some 38 seconds. So I'll explore the changes for the 2.0 branch first. And as the first change, you can see that we're also making optional changes. So in this case, we're removing the auto-wired annotation, which you've been able to do as of Spring Boot 2.0. But still, you're going to find that you have a lot of these throughout your code base still. And it's just not necessary. It makes your application feel like a dated application rather than something that was developed for Spring Boot 3. So we remove this any place that we can find it. And we also, for instance here, introduce text blocks when you're concatenating a string across multiple lines. It's these kind of optional changes that really make your application feel more recent. If we scroll further down, you can see that we're also replacing the JavaX validation imports with the Jakarta ones. We've migrated this test from JUnit 4 to JUnit 5. We've removed some visibility modifiers, and if you're ever wondering, well, why did we make this change? Well, we can tell you exactly why we're making these changes. The test changes are just part of the JUnit 4 to JUnit 5 migration, which is part of the Spring Boot 2.4 to 2.5. And we just run this just because we know that you have to migrate if you go to Spring Boot 3. If we scroll even further down, you can see that there's a lot of changes that you would otherwise have to have been making by hand. And we just want you to know that it's not necessary to make these changes by hand anymore. You can just run this one automation and get this all up and running. Here you can see that we're not just updating your code, we're also looking at properties. The Spring developers have a habit of renaming properties between versions that you're then going to have to find, either in your properties files or in a YAML file or in your config server. And it's annoying, because your compiler won't complain about this, but it will still be an issue at runtime. So what we do is we reliably find these properties, rename them for you, and make sure that the first run that you do will actually work. Now I want to take you to the pom.xml file just to show you the changes that we make there. And again, you can see we have to scroll past quite a lot of manual changes. But I know it's coming up. Yep. So here you can see we changed the parent version of Spring Boot to 3.0.7. We've not yet developed a recipe for 3.1, but I think we can fairly easily do that as well. It came out just last week. We need to update that as well. Next, we deduced that this is a property which will set the compiler, source, and target versions. So we're swapping that from 1.8 to 17. And we figured that this plugin is incompatible on the older version for Java 17, so we just bumped it to a compatible version. We also introduced some dependencies that you use to get transitively, just to ensure that your application remains working. And if you go even further down, you can see that, for instance, the Cobertura coverage plugin is incompatible with Java 17. So we've chosen to remove that. Now, ideally, you'll replace this with Jacoco, but that's not an automated change that you are comfortable making for you. So instead, we're going to make sure that your application will run on Java 17 and leave it up to you to plug in any new coverage plugin that you might want to use, such as Jacoco. Now, if you think this all looks good, you can either validate these results, which will kick off a CI pipeline, or if you're brave, you start a commit, and this can be either directly, or you create a pull request or a fork, whichever way fits your way of working best. Now, and then I think concludes this migration to from Spring 2.0 to 3.0. But I wanted to show you as well, like, why are we changing a project that is already on Spring Boot 3? Well, if you have a look at the changes there, you can see that even the reference implementation of the Spring Pet Clinic project still has some optional changes that we still can apply. For instance, here we no longer have to specify an annotation argument if it can also be deduced from the compiler argument. We also can introduce text blocks, as we've seen before, and we no longer have to add the auto-wired annotation. This is all still present in the main branch of the Spring Pandemic project. So if you want to ruin my next demo, you can commit these results, start a pull request, and it will be fixed the next time. But I want to highlight that this really goes to show that even on a reference implementation, it can make sense to do an automated migration, because you'd otherwise be missing out on some of these steps. So that's migrations covered. But then we figured, well, we have this system of making automated code changes. There's probably some more things that we can do that are of value to your project. And for that, I'm going to take you to a different recipe that we have. So we have a marketplace of recipes where you can find anything that might be applicable to your projects, such as changing anything for GitHub Actions or Quarkers or Micronaut, whatever you want. But in this case, I want to have a look at the common static analysis issues. If in your organization you're using a tool like SonarQube or Sonar Cloud, you will find that that probably gives you a good report of issues where you're not quite living up to the code standards that they'd want you to. But where they give you a report and tell you exactly what you should be changing, we figured we can do better than that. So we covered some of the same the same issues that they have, but turned them into recipes to actually apply the suggested code changes. And where before I showed you that we can run recipes against a single project, the Spring Pat Clinic, I want to show you that we can also run all of these fixes. There's some 60 plus well-known SonarQube issues, and we can run them against 140 repositories, which are just some well-known Spring projects and Netflix projects that we support in our platform. And as this is running, you can see that we have like an estimated time saving that keeps adding up as new results come in. And again, we can dive into individual code changes. And we will tell you exactly, like here we renamed a variable, and here we are splitting them out across different lines, and a lot of these changes, again, you would otherwise have to make by hand, but we just fully support you running all of this quite quickly against an entire organization to really make those graphs that you have in Sonar nosedive with all the technical depth that you're able to resolve quickly. Now we verify and test all the recipes that we have. So what we want you to be comfortable with is just select all of these changes that we proposed at the same time. In this case, some 200 hours of time savings, and just commit all of that. And then for that morning, you're done. You've solved all these SonarQube findings that were just at the top of your list, and you can actually start to focus on what would be the next most often found violations. So again, this is a great way of showing you that you can use these automations to really reduce any kind of issues that you have in your source code. And this is just showing you two aggregate recipes that we have, but there's quite a bit more we can do. So for instance, we have similar recipes to cross-reference all your dependencies and your transitive dependencies all the way down against the GitHub vulnerabilities database, and just resolve all of those vulnerabilities at the same time. And if you look further, we have a lot of best practice recipes as well to just make sure that you're able to type, just to resolve a lot of common issues within your code base. So I'd say that this is pretty convincing to have you look at what these automations could mean for your projects and start to apply these changes broadly and quickly, easily. And so with that, I think we're going to take you back to the presentation. Let me check. And full screen. So, as we've seen, through Open Rewrite, you can now upgrade quite easily between versions of Java and Spring with a single command. You can even migrate between frameworks, such as from JUnit to AssertJ, and even from Java EE to Spring. In this talk, I'll tell you all about Open Rewrite, how we're actually able to make all of these code changes. I'll tell you how the project came about, how it works, and what you can do with it. And finally, we'll briefly look at who's developing these recipes and how to apply them to open source projects. So, Open Rewrite was started at Netflix, initially to aid in the migration of an internal logging framework to SLF4J. You can probably imagine that any logging framework is going to be pervasive throughout an organization. To even consider migrating, you'd need perfectly accurate automation, especially when usage is spread across hundreds of services. So they developed a parser to accurately read Java and turn the source code into a lossless semantic tree. This model can then be modified to replace the old logging statements with calls to SLF4J. And next, the migrated model is written out as close as possible to the original source code. This way, the applied changes are minimal, leaving surrounding code untouched. And later, the same developers moved on to work on Spinnaker. And while trying to onboard teams and organizations there, they found that teams often struggled with these same outdated language and framework versions. To help these teams adopt the latest versions, they applied a different set of transformations through the same lossless semantic tree parser. This allowed them to quickly reduce this technical debt, bringing teams from Spring Boot 1 to 2 and from JUnit 4 to JUnit 5. The project has since been open sourced, with the company behind it committed to making all recipes available on the Apache license for open source software. The initial focus for Open Rewrite is on Java virtual machine languages and surrounding technologies. There are parsers for Java, Groovy, Kotlin, YAML, and XML. And these in turn unlock support for build tools such as Maven and Gradle, and ultimately libraries such as JUnit, AssertJ, and Guava. In the end, you're able to migrate entire frameworks and platforms with recipes available for application frameworks such as Micronaut, Quarkus, and Spring. Open Rewrite is not the only parser capable of understanding and manipulating Java. However, there are 3 benefits that you get with Open Rewrite that you wouldn't get with any other implementation. The first is our focus on exact type attribution. By having the exact type available on any tree element, we can be sure to only manipulate exact matches. Other parsers might skip this deep type attribution step to get better performance, but then lack the ability to match and apply certain transformations. The second characteristic that sets Open Rewrite apart is our format preservation. We not only take into account the functional code, but also the surrounding code style and indentation. This allows us to accurately reproduce your source file, regardless of further changes. Any changes made through Open Rewrite will look just like a colleague worked on your code. And this is different than from, for instance, Google Error Prone, which forces you to use an opinionated formatter, which might not be a big deal in some cases, but when you have 20 years worth of commit history, you might not want to reformat all of that just for some simple replacements. And finally, our serialization format ensures that you're able to query and refactor your code faster and at scale. And together, these features make Open Rewrite exceptionally good at safe code transformations. The changes are minimally invasive and guaranteed to work, in part due to our do no harm mentality. By manipulating the full lossless semantic tree, Open Rewrite can far exceed simple search and replace operations. With the full lossless semantic tree built, we need to instruct Open Rewrite what operations to apply and where to apply them in your code. Recipes are how you define such a group of search and refactoring operations. Together, they accomplish a higher level task, such as a framework migration. Recipes can consist of a single standalone operation or be linked together with other recipes. Open Rewrite comes with a large collection of fine-grained recipes out of the box that can be combined for common migration steps. You can think of these as Lego building blocks, ready to be applied with the proper parameters. There are hundreds of these building blocks to, for instance, change types, change methods, change arguments, manipulate properties, and alter dependencies and plugins. Individual recipes are implemented as a Java visitor that first matches and then modifies elements of the lossless semantic tree. There are plenty of examples available, but note that you only need a dedicated Java visitor when none of the existing recipes can already achieve your goal. Typically, you can get very far only configuring, combining, and applying existing recipes through a YAML description file. Modules then group together these fine-grained recipes into more coarse-grained, application-specific recipes. There are modules, for example, for logging frameworks, testing frameworks, and application frameworks, such as Spring. Think of these as Lego sets, with build plans for common migrations and fixes, ready to be used. In my opinion, the lossless semantic tree, combined with the large collection of open source recipes, is what sets OpenRewrite apart from other similar tools, such as Google Error-Prone's Refaster. Now I want to show you briefly how recipes are configured in OpenRewrite. Let's briefly look at a migration from JUnit 4 to JUnit 5. I want you to imagine what steps would be needed for such a migration. You likely know a couple of these steps already. Among others, you would have to update the test annotations, but you would also have to update the assertions, and sometimes the argument order. You'd have to update all imports, you'd have to update any test rules, and that's just getting started. Notice how each step is reflected as a separate recipe in this YAML configuration file. Some refer to and configure generic steps, such as the change type recipe. Others are implemented as an imperative step, a dedicated Java visitor that first matches and then modifies elements of the lossless semantic tree. And all these steps combine to achieve a complete JUnit 5 migration. And this is a common pattern with OpenRewrite. Large migrations are broken up into small reusable steps. When we run this recipe, we get predictable results, as you've seen in the demo. Our imports are converted as we would expect, and our Makito runner is converted into using the extension. Lifecycle annotations are correctly replaced. But interestingly, we can see how OpenRewrite shines through when it comes to converting expected exceptions. Having the full power of a lossless semantic tree, combined with a Java visitor, allows us to adopt assert throws. And this would not be possible with just any regular expression approach. And it's just a small sample of the types of transformations that are possible. Running migration recipes is fairly straightforward. First, you apply a build tool plugin for OpenRewrite. I've used Maven in my example, but Gradle works just as well. Then, depending on the changes you want to make, you add a dependency on the respective OpenRewrite module. And lastly, you run the OpenRewrite plugin with the recipe that you want to execute. The commands shown here will migrate your application to the latest version of Spring Boot. And this works all the way back to Spring Boot 1.5. This will update dependencies, properties, deprecations from any older versions, and it includes the JUnit 5 migration, as you've seen before, as well as any Spring-specific test constructs. So now that we've seen how OpenRewrite works, let's have a look what else you can do with it. Obviously, by now you've seen it as well suited to migrations. You've mostly seen migrations from one version to another, but you can also migrate from one framework to another. If you want to switch from log4j to SLF4j, you can. And the same thing if you want to switch from JUnit to AssertJ. And even larger migrations are in development. Another application, as I've showed you, is static analysis findings. A large collection of check style, sonar, and security findings are supported to allow you to reduce the technical debt in minutes. And finally, there's a whole class of recipes to enforce a certain code style. And rather than merely apply a formatter, these style recipes go a step further to actually change your code. This ensures your code style reads consistently from project to project. And in addition to what's already available, it's fairly easy to add custom recipes specific to your project. So now that we've seen how it works and what you can do, let's briefly look ahead at what is still to come. As you've seen, Open Rewrite has dedicated parsers for multiple languages already. But as you can imagine, we have some catching up to do still. We are further refining our parsers for both Java 21 and Kotlin. And note that you're perfectly able to run on Java 17 Plus, but you can't yet migrate to some of the new language features. The interesting thing about Kotlin is that our Java migration recipes will also just work. So if you have a Kotlin application using Spring, you can use the same recipes that we have to migrate that application as well. And that's even though the languages look a bit different. And we're testing this now together with the team behind the popular Kotlin Arrow framework, who are using Open Rewrite to migrate people to their latest version. We're also looking to make it even easier to define migration recipes by using the approach popularized in Google Aeroprone's Refaster. And while this won't be able to cover all cases, it is convenient when it can. We're also working on a CLI to make it easier to run recipes without changing the build. And using this to integrate with, for instance, GitHub Actions and GitLab CI for feedback on your pull requests. And we're also branching out into new language families. We recently added a parser for Python, and in a couple of weeks we'll have one for TypeScript as well. All of these features are in active development. It's not exactly clear when you can use some of that, but it is interesting developments nonetheless. Now I want to call out the Refaster template specifically here, as it will make recipe development a whole lot easier. As you can see here, we define a before template of the pattern that we want to replace as an annotated method, taking in an argument. Then secondly, we define an after template with the code pattern that we want to see instead. These patterns are then matched throughout your code base and replaced with ease. We like this approach so much that we're not just going to copy it, but instead we're going to use exactly these annotations. That also allows us to leverage the work of others, such as, for instance, at Picnic, who have defined and open sourced their Refaster templates. Our users then get the benefit of applying Refaster recipes at scale without the Google Java format enforced by Aeroprone. And if you need more than Aeroprone can support, we allow you to gradually switch to Open Rewrite recipes. Now, as a last subject, I want to tell you a bit about the company behind Open Rewrite. As I said before, Modern has committed to making all recipes available open source. You can run Open Rewrite on your own machine against any project that you like, including private code. It will work, but it won't be quick, and it will only update a single project at a time. With Modern, our focus is on applying recipes at scale. Through Modern, our clients can discover code patterns across their entire organization and target these for transformation. And even if you're not a paying customer, you can still use our web interface to browse available recipes and even apply them to open source projects, as you've seen me do in the demo. This can be a great way to start contributing back to open source software. And if you find that any migration steps are missing, Open Rewrite itself is very accepting of new contributions. The community plays a large role in the development of new recipes. And as you could maybe tell from my email address, tim@modern.io, we're not exactly a big company, but we're pretty well connected into the broader Java community. Through collaborations, other companies contribute migration recipes for their frameworks. These ensure that their users are able to migrate easily and timely with new releases. And if you maintain or merely enjoy a certain library or framework, you can help all other users by providing migration recipes. And this is something that I do on the weekend as well. So I've added migration recipes to frameworks such as Wicked and Axon just to ensure that their users are able to migrate easily. And I've been using the platform to do some maintenance on Apache Maven. So the Apache Maven project has a very rich history, and as a result of that, they're using some patterns that they're not quite pleased with. So for instance, if you go to their backlog, you can find that this issue, where they have not one, not two, not three, but 4 different instances of string utilities classes. And I even found a 5th one, which is only in one project. And all of them do the silliest things, like checking if a string is empty. You don't really need a utilities class to check if a string is empty. You just check, is this string null or is it empty? Just use the JDK. And what they're looking to do is phase out all of these different dependencies and then get rid of, I think, a couple megabytes worth of useless dependencies that are just not needed when you run anything. So what I've done with our platform is define an initial set of recipes to just replace this simple, is the string empty or is it not empty, with a recipe. And I can take you through that recipe right here. So as you can see, we're going to replace any calls to any kind of string utils that is empty. And that can be in the commons lang or shared utils or plexes or whatever they. And we're going to replace that with just a call to check, is it null or is it empty? And this might seem silly, but they had this some 2,000 times across some 90 repositories. And it's just silly stuff. We want to get rid of this, but no one in their right mind is going to do this on the weekend unless you have this automation to actually run it in a couple minutes. So if you look at how we've implemented this recipe, it's fairly straightforward. So we have a matcher. Well, let me close this one, which will just match any calls to is empty or is not empty. And if we find a match, we replace them with a replacement defined in this lambda. Now, as you've seen with the refaster templates, this will be even easier. But for now, this is how we've implemented it. Then we do some checks, and if we're actually fairly confident, we check, could we remove the import as well, just to make sure that we don't have any dangling imports. And then we do the replacement. And this way, I've been able to open some 50, 60 pull requests to Apache Maven in just a couple minutes. I had one guy very kindly offer to actually review all of this, which you think, well, that's not fun, but he kindly offered, so I'm quite pleased with that. And if you're wondering, well, how do I actually test all of this? Well, we just have unit tests. Any Java visitor is just going to be a program that you can run, and we have a framework to unit test that as well. So we define a before situation and an after situation that we want to use. And then as a parameterized test, we're able to verify that we're able to support the exact cases that we want to replace. And this is for the is not empty, is empty case, and is not empty case. But we also have one where it's negated. So we make sure that we're still using not changing the behavior of the code. And if there's any cases where we don't want to do replaces, such as, for instance, if you do a method call, we don't want to make that method call twice. So we just assert that we're not making any changes in those particular cases. Now, the only fun bit of feedback that I got from the Apache project on this was that one of the contributors asked me if, for every automated pull request that I open, if I would be so kind as to also open a Jira ticket. And at that point, you kind of want to see, does your process really match the reality of making code changes at scale? In the end, we were able to push back on that, and I've not had to do it, luckily. So let me switch back again. So yeah, the upcoming versions of Apache Maven will have my commits in there. And if you want to contribute and do similar changes, there's a lot more that we want to replace, which is just going to be simple replacements that you can run through the platform. And you can do the same on any other project that we support. There's some 30,000 projects in the public platform, and we really invite you to engage with library and framework authors and use the framework to make those changes. And so with that, we are getting near the end of my presentation. Before I send you on your way, I want to recommend a few resources where you can learn more. Firstly, there's extensive documentation available on OpenRewrite at docs.openrewrite.org. This is the same link that I told you. If you only remember one thing, have it be this one. All our development is on GitHub, with new suggestions picked up with surprising speed. And as we've seen already, it's fairly easy to contribute minor migration steps. If you want to try some recipes quickly on open source projects, have a look at public.modern.io. That's the website I used in the demo, and you're free to use that as well. And if you have any questions, you can reach out either on our public Slack or via email, whichever you prefer. And finally, if you would like to play around with some of the commands that I've shown you before, I've written a blog post to accompany this presentation. The blog post migrates an old Spring Pet Clinic branch from 1.5 on Java 8 to 2.x on Java 17, because I wrote this a year ago. And that way you were able to play around with the commands and see the changes that are made at every step. For your own projects, I recommend you start with the testing framework migrations. They're an easy way to gain confidence in the tool and see what it can mean for your projects. And with that, I'd like to thank you all for your attention. Are there any questions? Yeah.
First of all, that's great talk and also providing migrations. If I got you right, you mentioned that you regularly contribute recipes to different. If I got you right, you said that you regularly contribute recipes for different frameworks.
Mm-hmm.
But isn't also the case? Does it mean that the framework providers don't do this, and isn't it in their best interest to do this and involve with the community around OpenRewrite?
Yeah, so we have a mix of some frameworks we support just because they're often used, but the framework authors are not involved. And in other occasions, we have collaborations. So, for instance, with VMware for Spring, with Oracle for Micronaut, and for Red Hat for Quarkus, all of those original framework authors, they are involved. So they are actually contributing these recipes to make sure that their users are able to migrate. Because it's a benefit to them as well. Their users will be more happy to upgrade to the latest version, and they only have to maintain the last one and the recipes to get you there. So yeah.
But not with all, obviously.
Not all. No, we're trying to branch out, but we need that buy-in. Like, we have enough credibility with the existing ones, but it's also you need a certain set of skills to develop these recipes, and not every library or framework author has that capacity to do it.
Okay.
So in that case, we're really thankful for anyone in the community to develop those recipes. So yeah.
Okay. Thanks. That's great as well.
Yeah, cheers.
Hello, thank you for the great talk. I'm just wondering regarding your sample with string utils is empty. It's kind of possible that in some cases it's very evident from the code above that the argument of is empty is already not null.
Yep.
And in this case, now check will be redundant. Can OpenRewrite infer this and remove redundant check automatically?
Not right now. We can't yet infer if it's nullable, but we're looking to add this to the type system that we have, so that we are able to change our behavior if we know that it is null or guaranteed not to be null. So that's something that we noticed as well. It seems silly to add a null check if you know that it's not going to be null. So we're looking to improve, but it's we're not a big company. We're trying continuously to improve these kind of things as well.
And there are also, I saw in tests that you showed that sometimes double negation is created because negation was in original code and you are adding another negation. Can it be cleaned up automatically after that?
So we have recipes to clean that up after the fact. And those are very easy to do with the refaster style of template. So we're leaving that in for now. We've decided, because we're phasing out those method calls, that we're not going to first do the negation and then do the cleanup. But we're just going to run that cleanup and find any similar instances elsewhere still.
I'm also wondering that implementation of replace template. You have something like Java template.compile or something and press lambda there. How exactly does it work? Is it some bytecode magic or something?
I have more technical colleagues who can tell you exactly how that works. I can probably try to find out, but I can't recall that exactly right now. So we do invoke the parser to check what it actually produces. But yeah, the really big details, I invite you to join our Slack and we can discuss that there.
Okay, thank you very much.
Cheers.
Hi.
And don't forget, I have stickers. I keep forgetting to tell people, so I put it on the slide. Come find me if you want a sticker.
Hi, great
Cheers.
talk and great product. You mentioned you have some integrations about rules from SonarCube. Do you have some integrations or plans to integrate with Snook, Problem Sneak, because they're more vulnerability oriented?
So the recipe that I only didn't show you the results of is the checking for any vulnerabilities and transitive dependency vulnerabilities that we have. So we're able to do a similar functional thing there, but we don't integrate with Sneak because we figured, well, we have our own model, we have our own database of vulnerabilities, or the GitHub database of vulnerabilities that we use right now. So we're able to do the exact same type of changes, but it's not as an integration with.
Cool, that's fair enough. Thanks.
Cheers. Oh, one more in the back.
I am just curious about the capacity of the tool. I've had one or two instances where I had to downgrade. Is it a possibility for you to do that?
We actually had a very poor person in our community develop recipes to change code from Java 17 back to 11. So we're able to define recipes, but it gets tricky quite quickly, because if you have a record that is maybe defined locally, you have to generate a name for it, and there's some things you can do, but it's hard to do reliably. So we can get you part of the way there, but likely you just want to talk with management again and try to get upgraded to the latest version, because it's no longer like a time investment. It's just something you do, and that you do continuously, not once every 5 years. Cheers. So if there's no further questions, feel free to come up as well, and then thank you all again. Cheers.
All right, so hello everyone and welcome to the next session. So our next speaker is Emily Young. She's working at IBM and she's a Liberty Microservices architect. So today she'll talk to us about microprofile. What's the future of microprofile? Quite an interesting topic. So Emily, you have the word.
Yeah, thank you. Thanks for coming, everybody. This is a beautiful day, and I was told that the weather here was not very good, but so far, oh, don't drink it. so far it's good. So it's my. Have you had a good time today? Yeah, great. In this talk, I'm talking about macro profile. So basically, it's up-to-date information with macro profile. Can we show hands? Who knows about macro profile? Wow, that's great crowd here. So hopefully, if you do not know about macro profile, also this session will equip you with up-to-date information about macro profile. And later on, I will do a demo to show the current release on macro profile. So let's get started. So we'll talk about 3 parts, a quick overview, and then the latest release about macro profile 6, and also talk a little bit about future of macro profile. So macro profile is under Eclipse Foundation. It's supported by many members, including IBM, Red Hat, Oracle, Microsoft, and a few JAX, Tommy Tribe, and others. Basically every time when we do release, and all the members need to support the release and etc. When we say macro profile, actually is open source standard for doing cloud native application development. So this is a true open standard because it's implemented by many implementations, such as in IBM, we have Open Liberty. Who knows about Open Liberty? Okay, great. And also WebSphere Liberty, basically repackaged Open Liberty, and also has Wildfly. Who knows about Wildfly? Okay, great. Wildfly, Payara, Quarkus, Halidon, etc. So there's many implementations for you to choose from. So this is great because you got a computation, and also all the vendors collaborate together and at the same time compete with each other. So the end user will get a real benefit from it. So this is basic chart about from the beginning, the macro profile back in 2016 to 2022, which is kind of the late, December last year, we had a macro profile 6 release. So in this talk, I will just talk about what's in offer for macro profile 6. So this is the kind of the current status about macro profile is based on the Jakarta EE 10 core profile. Who knows Jakarta EE? Okay, great. Similar a crowd. And also in the umbrella release, there's a telemetry, open API, REST client, config, fault tolerance metrics, and health, and etc. And then on the right hand is standalone release. Basically, it's not part of the platform. So they have their own release cycle, and they can mix and match together with macro profile umbrella release. So such if you do reactive messaging, and then if you do you can work with macro profile 6, for example, reactive messaging 3.0. And if you do a transaction, you might be interested in the long-running actions. Or GraphQL, you might be interested, if you want to do a lot of queries and view data, you might be interested in GraphQL and etc. At the moment, who is using macro profile 6? Okay, 5? Okay, earlier version? Okay, just a few. So the rest of you is a greater chance for you to learn about macro profile to see how can you use it in your projects. There's, I know Eva has a session tomorrow. We'll talk about, Eva over there, talk about Jakarta EE. If you are interested, I think I highly recommend to come to his talk to learn about Jakarta EE. And Grace here is going to talk about a lot like open liberty and also performance boost and etc. Also, it's yeah, it's a great session tomorrow as well. For Jakarta EE core profile, there's about 7 specifications: CDI, like interceptor annotation, JSON B, JSON P, and Jakarta REST. Who knows about CDI? CDI? Okay, a few of them. A few of you. Who knows about Spring? Spring Source? Spring Boot? Okay, great. So it's for CDI, it's similar to the Spring like injection. If you do an apt-inject, it's similar to the auto-wired. But CDI Lite is a new is a new part in the CDI specification, and then lifted the part to be added to the Jakarta E10 core profile. So macro profile consume the whole Jakarta E10 core profile. So this is the big picture about what's on offer in the macro profile 6. I will quickly go through like the update. You can see the update like telemetry, which is based on the open telemetry under CNCF. Who knows about open telemetry? Okay, great. So it's later on I will have a demo to demonstrate how easily to use open telemetry in your like microservices via macro profile telemetry. And also Open API, there's an update. Who knows Open API? Okay, that's great. So you know Open API already. So it's I think it's the metrics and the who knows the job wizard? Job wizard? Okay. Who knows about a macrometer? Okay, that's good. So this macro profile metrics 5.0 will be able to like basically for the implementer to consume macrometer and support macro profile metrics APIs. And also that JWT authentication has some update. So in this talk, I will talk more about macro profile telemetry. So you will understand the OTel, and also I will talk about more about the macro profile metrics. So basically, you will learn how can you use the macro profile to do your observability for your microservices. So I quickly go through the Open API. So Open API has the integration with beam validation. So if you do add positive here, it automatically can generate like the documented here. You don't need to. And the other thing is the security requirement. You can do like either or and style. So the other thing is additional properties, and you can just specify the schema, and then it automatically can generate the documentation for you. If you know Swagger is pretty much is kind of is a no-brainer here for you to understand it. So API response, so you can use on the class level and applicable to all the methods here. So next thing is extensions. Oh, what happened? Oh. My laptop is trying to crash. So it's and then extensions attribute can be added to the like extension. So basically, if you specify add extension name value pair, can automatically like being documented in this output for the Swagger output, if you know Swagger. And the next one is quickly go through the microprofile GWT. When you secure microservices, the the one is common approach, you use the Jakarta security. So you use the rules allowed to permit or deny some access. For microprofile GWT, basically adopt GWT and also the OAuth 2 and OpenID Connect, all these the technologies. And what is the offer? What is provide beyond the microprofile, beyond the GWT is to it added 2 actual claims. One is UPN, is about your user information. The other one is groups, basically which group, access group you belong to. And then package this information together with your GWT token and in the pass downstream. So it's as the the HTTP header. And then downstream automatically get this token and open it up, can check which access group you belong to, and then against which access group you are allowed to access the backend, and then can make a judgment whether this incoming request is allowed to access the backend or not. So this is the GWT. So it's, in this release, it's added a few configuration. So it's basically, it says how long this token will live in second. The other thing is about a clock screw. So basically, this change the times between the 2 different systems. So it's basically some like operating system have 1 second between 1 second time difference between with the other one. In this case, you can do the adjustment like a clock screw. The other one is when you pass on the JSON Web Token, and sometimes you can do a signed jot, or you can do encrypted jot. And if you do an encrypted jot, so that would be a GWE. And then there's a new configuration to say what kind of algorithm is allowed to decrypt this GWE token. So this is all the configuration is added for the GWT. Okay, so the next major point, I will talk about microprofile metrics. So for macroprofile metrics and macroprofile telemetry, this is all about observability. If you do cloud native application development, observability is really, really important. You have to think about how can you diagnose some problems, how can you take any precaution if something happening. So it's prior to macroprofile metrics for the 5.0, macroprofile metrics was based on Job Wizard. But obviously, gradually people move towards macrometer. Now is a lot more people move towards open telemetry metrics. Basically, that's all the upcoming. So there's a real need for macroprofile to rebase the technology. So it's this is macroprofile metrics 5.0. Basically, it still have some macroprofile APIs. However, it also has a really great a CDI integration. So you can inject the timer, you can do the histogram and etc. Also, it supports multi-dimensional metrics, which is the highlight for macrometer. So you can see like a driver in this example here, the car speed, you can see who is the driver, so which speed is identify for. And also, there's another great feature for macroprofile metrics 5.0 is it can aggregate the metrics based on the scope, customer scope. For example, if you are the consultant, you will say, okay, it's Emily scope. Okay, I create all these metrics. I can list out what kind of metrics I created. So this is great for consultant. If you have a project, they say, okay, I want you to provide this kind of metrics. You can demonstrate that, yeah, this is the metrics for you. So this is kind of the, the customer scope support. And also the API has been reworked so that the implementation can bring in either a macrometer or some other the metrics libraries such as open telemetry metrics and etc. So a few quick words about macrometer. Macrometer actually is a Java-based libraries. It's only for Java, and then there's quite a lot basically support monitoring libraries and monitoring tools for you to work with. So this is basically all the Spring application Spring Boot to adopt the macrometer is being developed in that community anyway. So the other open source community is called Open Telemetry. Open Telemetry actually is language agnostic. It works with Java, with Node, with Python, with many languages. And also it has 3 pillars. One is tracing, one is logging, the other one is metrics. So far, only tracing, all these APIs are stable, only tracing are stable. And logging and metrics are still not stable, so it's still under active development. So it's at the moment, and a lot analytics tools works greatly with open telemetry. One thing I think is open telemetry is going to have a huge impact in this a cloud native application the industry, because it's language agnostic. In the future, even if in your company you do cloud native applications, I think the applications will be in multiple languages. However, you really want to know to make them interact with each other. So analytics too need to be same. So basically, you need to have the similar, understandable tracing information or metrics information, no matter what kind of language your application was developed with. So this is open telemetry. So it's at the moment, who is using open telemetry in your production? Okay, 3. Who is using open telemetry tracing? Metrics? Logging? Okay, logging. That's interesting because logging is not quite stable yet. Okay, that's good. So for the metrics, basically is in macro profile metrics, there's one endpoint slash metrics, return all of metrics. And also you can do metrics question mark, scope equals some scope, you can get all the metrics basically provided by that scope. And you can even view a particular metric. So you do an ampersand, name equals metric name. And in OpenLiberty, we implement macro profile metrics 5.0. And it provided vendor metrics, also some basic metrics, and about class loading, about memory, and etc. About the garbage collector status, and also we provide we used macrometer, so as a library to implement macro profile metrics, and then it works with many of the monitoring system. So Autobox. So directly we have this registry, Prometheus registry, and you can plug in your own Elastic Meter registry, New Relic, and Dynatrace, and etc. So this is kind of the OpenLiberty's feature. It's called MP Metrics -5.0. So this will give you all the APIs you need for using macro profile metrics. So to rework the current macro profile metrics, so previously was based on Job Wizard. So some APIs has been deleted, reworked, like a simple timer, concurrent gauge and meter been deleted, and some of them been updated. So simple, this annotation, simply timed and metered and concurrent gauge been removed. So this is a more like a API update. So here is the matrix registry. And this registry type was corresponding to job wizard, but in the micrometer is kind of the geared towards the registry scope. So this is some update. So more updates, the other thing I want to highlight is the micrometer is basically use a percentile, like 75, 95, this percentile. So this is was added as a consequence. I will give you a quick overview about microperform metrics. One thing I want to mention is even if you use a micrometer, you need to bootstrap your micrometer, right? You need to create your scope, your registry, registry scope and etc. However, if you use microperform metrics, and this is all done by you, for you, and also you can directly use some APIs, just focus, create your metrics, and then add the metrics into your application. Let's quickly go to the code here. So it's I have all the things set up. However, I do not know what happened. Is automatically everything was teared down. So it's so here, like in this, can you see it? Okay. You see. So it's so in the matrix here, like you can create your matrix. Let me quickly start the So let me start the application now. So let me start it. Oh. Anyway, let me quickly walk you through the car metrics here. So the car metrics, so basically you can create the metrics registry. So the metrics registry, and basically you create a bin there. So this is a CDI bin, like you just say application scoped, and then is the kind of the you inject. So basically this is construct injection. You inject registry scope, and then the scope is car scope. And then is the kind of the, in this registry, you can specify the gauge, basically car locked, car speed, and also is you can create a metadata builder, so with name, description, etc. And then is kind of the driver timer and driver time context, and also the here is the speed update. Basically, you create the histogram in this registry, and then in the car controller, so basically you drive the car and lock the car, and also the beauty is you can directly inject the car metrics. So you inject the car metrics, you can start a speed thread, and then you can just lock the car, unlock the car. So basically, this set all the state, and then you do the start driving, end driving. In the start driving, basically, and then you simulate the start speed thread, and then is kind of this is just give you a random number about this speed. And this is a highlight. Basically, you can do a matrix or speaker update. So update the speed. So you will get the histogram for that. So it's let me see whether that one. Cool. So the car is So this is kind of the previously. Basically, the car is driving. And the metrics, so this is all in the container, so I have to restart everything, restart all of my Docker image. So while it's starting, I will keep talking to the the next one. So it's, let me quickly go back to here. So it's, for the telemetry. So that's the quick summary about the metrics. So the other one is macro profile telemetry. So macro profile telemetry is based on the open telemetry. And then is kind of had the bit integration with the some Jakarta technologies and also macro profile technologies as well. So it's for the macro profile telemetry 1.0, we adopt open telemetry tracing because that's stable. However, by default, so it's open telemetry tracing is disabled. So you can set. This is the open telemetry config otel.sdk.disable equals false to enable tracing. And then it supports 3-level instrumentation. The first one is automatic. So basically, if you are doing REST calls, if you are using Jakarta REST or if you're using microprofile REST client, and then it's all of the traffic will automatically be traced. You do not need to do anything. The only thing you need to just set is you want to have a traced. So that's all. The other thing is the manual instrumentation. Manual instrumentation, basically, if you are not satisfied with just with automatic instrumentation, so this is merely all the REST calls. And for some additional trace you want, you can inject a tracer and also inject a span, and to be able to add additional tracing information. And the third one is agent instrumentation. For agent instrumentation, basically you attach the OpenTelemetry Java agent when you start a JVM, you directly attach that jar, and it automatically basically is instrument all of your traffic the going through the client to server 1, server 2, and etc. So this is applicable if this agent instrumentation you do not you couldn't update your code to add any additional tracing, and you could just directly use the Java agent to inspect everything, all the traffic. So it has a good CDI integration. So with the macro profile telemetry, so you can inject open telemetry or tracer or span or baggage, and etc. So this is the graph about from the client to service. Basically, you have two microservices, service 1 and service 2. So basically, it's kind of the request coming in here, and then this traffic route to this service 2. So it's basically all these trees. So this is automatically traced, and it will create a span, and the span will send to the open telemetry collector agent. So it's similarly, its most popular format is OTLP. So this is going to be the mainstream format. So you can do the Jaeger format or or Zipkin format, however OTLP format is going to be the recommended the format. And then it's kind of you can get all the trees in, and eventually you can get it viewed in either in the Jaeger or Zipkin backend, Jaeger or Zipkin. So for macro profile telemetry, so you can, as I mentioned, you can automatically tracing Jakarta REST or macro profile REST client, and then you can use this annotation with the span, span attribute, and also you can inject all these APIs. For the exporter, so you can export a span to Zipkin, Jaeger, and others. And also it also supports some other connectors. And the connectors coming up quite frequently. I know there's some other Google connector and etc. So it's as you can see, OTL has a great community surrounding it. Let's have a look the demo. So I have a few more minutes. So I will go to a different app. So in this example, so basically is this example I use a macro profile starter, so directly create 2 microservices. Let me see. At least Docker is running. With running, let me quickly. Let me we start Jaeger. Okay, Jaeger is up. So it's in here. So I use the macro profile starter. So it's start.macroprofile.io. So basically, you can create applications 2 microservices directly from here. So you can choose which version you want, maybe 5.0. And then you can choose runtime, and also you can pick any kind of technology you want to demonstrate. And you can take all of them to get the feel of it. So it's, I created that 2 microservices, basically service A call into service B. Let me directly start 2 services. Oh, server is already running. Let me stop it because of the crash. Stop. Let me see, start. Okay, service A. I start this dev mode. And then it will install the feature first, macro profile 6, and then it's going up. And then service B. Okay, as a service A. Maven Liberty Dev. So it's these are two services. So it's basically the service A directly call into service B. So I know service A it says in the 1982. So this is all up. So I know it's kind of this is if you have not heard of macro profile, so basically have not seen. So this is a matrix. So it's all the kind of the matrix data you can see, basically the CPU and memory and etc. The garbage collector and also the kind of the innovations and etc. So it's then if I call this one, so basically the call into the service B. So I just directed to say here, this is the service B. If you ask, is that real service B? So if I just do a same service B, I can do JPrime service B. Save that. Now, if I go back, see, you can see JPrime service B. Yeah, it's directly called into the backend. And now, a year ago, should be up running. So now I don't have any kind of the, I don't have any JPrime service A kind of the trace and etc. I have a service B trace. Now I want a trace from service A to service B, but I said by default there's no trace. That's because in my service A, so I said OTel.SDK.disabled true. If here I change it to be false. If I change it to be false there and I save it, now if I invoke it again, I invoke it here again, do a couple of invocations. Now if I do a finding trace, you can see, so this is being traced, right? It's traced and find trace. You can see here, these two span automatically basically is correlated. So to form one trace, you can see this is service A and this is service B. So it's additionally, if you really want basically add some like manual trees and etc. So you can do so. So let's have a look. In the service A, for example, in service A, I can directly inject like a tracer here. I can inject a tracer. So this tracer is this is the open telemetry contact the scope. So this is open telemetry tracer. And then I can say basically I want to create a span, so my span, and also I make it to be a current, and then is make it a current, and then I return a result. So it's always the best practice is you can just do a try in the try scope, so that scope automatically closes when you finish. So now, if I save that, if I go back to go back here, if I directly call in here a few times, now I'm going back here. I find the trace. You see, matrix data. Save that, and go back. You can see the you can see JPrime. This is a few seconds ago. Create a trace. Should have one span. Is one span is called my span. Let me see why. Make a current span. The tracer. You see the console terminal. Oh, it runtime exception. Okay, let me stop that. Let me start again. And it should I mean automatically create another span. Let me see. It's not quite saving that, but anyway, I will figure out why. But for the metrics, and also you can query the scope. For example, this scope, you can say base. So you can see base scope or application scope, and you can get all the different metrics. And then let's quickly use the next few minutes to talk about the future. So it's in microprofile 6 and Jakarta E10 is fully supported by OpenTelemetry, like the recent release 2303 and being released in April. And also is fully available to the any further on releases. And you can view the OpenTelemetry.io/blog and to learn how to use them. So this is kind of compatible implementation details. So there's gradually there's more implementations will come up on this web page. So compatible implementation. So for the future, so it's, basically we are going to deliver more macro profile releases and also work on more like specifications, add more annotation, more like innovations. Also is working like a spread word and also establish some champion program and grow compatible implementations. And also like have a closer relationship with Jakarta technologies. And for the future, we're evaluating more new specifications such as like cloud storage, converters, distributed cache. If you know, like there's a Java cache, but because of IP issues and etc., it was never moved to Jakarta. So there's a space about distributed cache. And also interesting in the serverless programming model. And I mentioned earlier, Open Telemetry has a metrics pillar and a logging pillar. However, like because they are still under development, and we are trying to like collaborate with Open Telemetry, and then is when the API is stable, we will just try to adopt the metrics and logging as well. Macro profile, as I mentioned earlier, built on top of the Jakarta EE. So it's, we follow closely with the Jakarta EE releases, and also is at the moment we are talking whether we do like very tightly coupled with Jakarta EE release or do loosely coupled with the Jakarta EE release. And at the same time, if you are already a Spring user and from now on, probably you will think is a macro profile actually is an alternative to Spring. So we constantly evaluate the gap with the Spring like framework. Also, because this is a Java technology, and we kind of monitor closely with all the new like Java releases, Java 21, etc. We also evaluate virtual thread usage in macro profile APIs. And also, like a macro profile, stay closely with a cloud. So we constantly evaluate if there's some new requirement from the cloud, and we would like to provide some kind of application APIs and etc. If you are interested, so this is kind of the plug here, and also I co-author a book called Practical Cloud Native Java Development with Macro Profile. So it's on Amazon. So this this is code, so you can scan to get Amazon directly page, or this is a short URL there. So with that, thank you for coming. I'm sorry for the crash or the kind of nearly crash the whole thing. And if you want to talk more about like a macro profile, find me here. Yeah, we can have like a closer talk and etc. Are there any questions? We have a kind of couple minutes for questions. Any questions? Okay, all clear then. Okay, with that, thank you so much for coming and enjoy the conference. Thanks.
No, like when you start talking, they'll figure it out. Okay, guys, the next session is, this is Margarita. She's from Kiev, but lives in Geneva and writes rules for Sonar. She's here with her whole family. Very sweet baby somewhere here, I guess.
Yeah.
I saw it like a while ago outside. That's pretty much it, yeah. Go ahead, yeah.
So, hello everyone, you can take your seats. Thanks a lot for being here and for such a warm welcome. It's my first time at JPrime and I already enjoyed the conference. I hope so do you. And today I'm going to talk with you about a healthy diet for your Java application with such a catchy title. And today we are going to talk more precisely about your memory consumption and memory leaks, out of memory errors, and so on. Before we start, let me introduce myself. I was already introduced. My name is Margarita. I work at Sonar. So you can see my Twitter handle. If you want to follow me, you can. Sometimes I post some technical stuff, sometimes stuff about work. And I'm a big fan of different programming languages like Java, Kotlin, Scala. And for my everyday job, I write static analysis for them. And there is one more important thing that you should know about me, that I'm Ukrainian. And you know, today we have a big problem with our neighbors. And currently we need all the support that you can give to us. So if you feel like you want to support Ukraine, you can use this QR code. It goes to some charity fund that helps Ukrainians. And feel free to scan it and help us. Thanks a lot for that. So the most important part of my presentation is done. Now I can breathe freely. So yeah. Short disclaimer. Today, what I'm going to present you, it's not a rocket science. Most likely, mostly all of you know everything about like memory, know everything that I'm going to talk to you today. But maybe this presentation will help you to have more structured knowledge and help you to actually use it in your daily work. And another disclaimer, there is no silver bullet. So every time like you face some problem with your memory, most likely you have to treat it differently, find some other solutions. But I'll try to give you some hints, some recipes, some maybe guidelines that you can use in your work and make your applications more memory efficient. So how it all started. Why actually I'm here talking about memory to you. Yeah, some time ago, you probably know this guy. If you don't know him, it's Alexei Shepilov. He is very famous for his contributions in OpenJDK, also for maintaining projects like GMH, GC Stress, Java Object Layout, and currently he is principal engineer in languages and runtime at Amazon Web Services. So pretty cool guy, known one. And in our company at Sonar, he is also famous for analyzing OpenJDK in Sonar Cloud. So basically, in Sonar Cloud, you can find OpenJDK that is analyzing the C++ and Java code. And one day, he came to us and said, I want to analyze my Java and C++ code in Sonar Cloud, which is a valid case, using 3 GB of RAM. We're like, OK, that could be tricky. And he cannot. So basically, when he tried to analyze his project in Sonar Cloud, it fell down with some out of memory. So that was some time to think. And like why it's so important for us. If you're using SonarQube or Sonar Cloud, most likely you're using it in pair with your continuous integration. So yeah, we provide you analysis, we provide you some nice UI in SonarQube, Sonar Cloud, but you pay for your machines. So you pay for analysis itself because it's machines probably in some Amazon or Azure or Google Cloud or in any other cloud providers. And so if we use more memory, you pay for this memory. And because we care about our customers, we'll try to be more memory efficient, and that's why this got our attention. And if you're using SonarLint, this is our plugin for IDE. You're using it inside your IDE and most likely using your local resources. So that's why we have to be efficient, because like your laptop might not be that, like we don't want your laptop to consume that much memory and energy. So we care about you, that's why we have to deal somehow. And it was exactly the same time when I get back to work after my maternity leave, and I have to come back in my shape, because I just gave birth. I was not in shape that I wanted to. And while analyzing these memory leaks and trying to get back in shape, in my brain everything mixed. So I found out a lot of similarities in the way how you can make your applications memory efficient and how you actually can become fit by yourself. So there was one question appeared in my head: am I making my application fit too? And that's how the idea of this talk appeared. So I come up with some algorithm, what you can do to make your application fit. First of all, the first thing that you should do before you start doing anything is like, is there any problem? Like, ask yourself, do you have a problem here? Why? Because I'm a Java developer, I don't want to think about memory. I want GC to do all the job. Because like using Java was the reason while back in the universities I stopped using C++ and started using Java, because I didn't want to care about memory, didn't want to write some destructors, whatever, because I thought like GC could do all the job. But garbage collector is not a wizard. It's great, but he cannot collect objects if they're referenced. And it's your job to make sure that something that you don't need is not referenced. So first of all, you have to answer the questions, do you have a problem? So what are the symptoms of potential problem with your memory consumption? If we are talking about body, because we have some analogy with fitness and getting back in shape, usually like what are the signs that I have a problem? My clothes are too small. I have higher fat percentage. It's difficult for me to run, work, or do any exercise. My BMI might be too high. I'm always hungry, and I'm actually not satisfied with my appearance. So the only reason why you should do something, if you are not satisfied, like if you look at the mirror and say, yeah, I am beautiful, I don't have any problem, maybe you should not like do anything because you're already satisfied. But if you are not, then you have to do something. The same with an application. Like, what are the symptoms of some problems with memory? First of all, out-of-memory error. The same as if your clothes are too small. You can just buy bigger clothes. The same, you can just give more memory. But if it's something that you don't want to pay for, if you want to reduce it, okay, maybe you have to look there. Another problem, poor performance. Sometimes, if you have some memory leaks, garbage collector cannot do their job, but they try to. And that's why it affects performance. You give more memory and it doesn't help. So sometimes this also signals about the problem. You spend much time on garbage collection, spend too much CPU, and so on. So there are some symptoms. And it's extremely important to understand that just one symptom could not say that you have a memory leak. For example, yeah. So you have to measure. The next step is about when you asked the question, is there any problem? And then you answered, yes, there is a problem. Let's start measuring. Because how you can reduce something if you don't know how much it is? So how can we measure? If we talk about body, it's weight, fat, muscles percentage, BMI, heart rate, blood tests, whatever. So whatever can help you to identify any problem works for you. And one of the most important is eating habits. Because firstly, to understand what diet you should follow, you should understand what you are eating currently. And then maybe you can minimize something. The same goes with your application. Firstly, you have to try to measure your performance. I know measuring performance is hard. It's probably another topic for a different, like maybe talk, or maybe you can have a full conference talking about performance. So my point is just try to measure it somehow. Another, CPU usage. Another problem, like if you have an out of memory, you should generate a heap dump to understand what caused the problem. And it's actually a good practice to do heap dumps from time to monitor what's going on there. So heap dump is another stuff that you can measure, logs, and whatever. So whatever you can find out, that will help you to investigate the problem. And it's very important to understand that just weight or just like usage of memory is not enough to say whether you have a memory leak or no. Because look at this graph. Is there any leak or no? How do you think? And the answer is like, I have no idea. I have no idea. Maybe it's just a normal natural consumption. Maybe it's just what your application should consume. And then if we have like a second graph, which is CPU usage or GC activity, you can see that, OK, on the graph, I can see that GC tried to do some job, but he failed. So maybe there is some problem. Maybe there is a leak, so it forces investigation. But if GC do their job and everything works fine, most likely there is no leak. So, and Alexei Shepelov, he understands all these pain points, how hard it is to debug memory leaks. He provided us heap dumps, logs, all the like even memory analysis to help us investigate everything. So he was a good guy. Every time you report to us any memory leak, please do like Alexei. And the first thing that we found out was like log. We found out that there was out of memory, and then our attention was caught by this stuff. So it's com.sonar.cpp something, and this package signals that this out of memory comes from C++ analyzer. That's great. I'm from Java analyzer. We are not those people. It's not us. Let's give it to C++ team. And now, be attentive. I have to reveal you one secret. It's a secret that will change your life. So if you don't want to hear it, just close your ears, because your life will never going to be the same. If you have out-of-memory error, and you have a stack trace, the best thing that you can do with a stack trace is to take it and throw it away. Because when we are analyzing out of memory, stack trace is almost useless. Because out of memory happens when you run out of memory. It doesn't mean that there is a problem with memory there. Problem could be much earlier. So that's exactly what happened. Like there was some problem earlier. Like for example, Java analyzer ate all of the memory. And then there was like tiny slice of memory left for C++ analyzer, and C++ analyzer could not like do their work, and that's why we got out of memory. So it would be unfair to go to C++ team and say, fix it, because problem was not there. So, and of course we didn't do that, because we understand that the problem was not there. So once we measured everything, we gathered all possible metrics, all the data that we have. That was time to analyze. And in order to analyze the heap dump, I think the best thing to do is to do some demo. So I'm going to use Visual VM and show you some small example. So I hope it's visible to you. So when you have heap dump, you look at this in Visual VM. I hope you already seen this UI. You have something like this. It's pretty hard to understand what's going on here. There are a lot of numbers, a lot of classes, but sometimes there should be something that catches your attention. In our case, for example, you see that byte array holds like 96.1% of memory. So maybe we can look and have a look what's going on there. So let's go here. Here we see all the instances of byte arrays. And what we can do, we can try to calculate GC roots. I've already pre-calculated it. And let's find out why this is still in memory. So you see that this byte array is value in some content, which is a full name class. Then it holds in some array list. And then, OK, you see static names cache, which is already tricky. So this value is still alive because somehow something static references it. If you go look at other instances, you can find that all of them are referenced in the same static field. Okay, let's get back to our presentation. And I have a question for you. So I'll ask you one question that is here, and I'll ask you to raise your hands if you would like to vote for this or that. So please raise your hand if you think that static fields are eligible for garbage collection when the last instance is collected. No one? Okay, that's the second option. When class instance is collected. Hey, raise your hands. I raise my hand that class instance is collected, so our field should be eligible for garbage collection. The third option, when JVM exits. Okay, makes sense. When class is unloaded. Cool. And none of the above. Come on. Okay, what can I tell you? Those of you who answered B, C, or D are halfly right. Because in order to answer this question, we need to understand a little bit how static works. Usually when we are working in Java, we are working with instances. So your object instance. And your instance usually holds a reference to the class of which we are the instance. And then class holds a reference to static field. So because it's static, it's not a field of your instance, it's a field of a class. So class knows about static field. And class also know about class loader that loaded the class. And then class loader knows about all the classes that it loaded. So basically, if you want to make your static field eligible for garbage collection, you have to make sure that it's not referenced, so there is no class, so class itself is garbage collected. And it means there are no instances, and it means that class loader is garbage collected. And when class loaders are garbage collected? Almost never. If you are using your default class loaders, they have the same life cycle as your JVM. So basically, everything that is static is forever in memory. So the most honest answer would be when class instance is collected and when class loader is collected together. Because it should happen simultaneously, because they hold a cyclic reference to each other. So static is like sugar. It's very easy to put it. We like it because it simplifies our lives. But the consequences could be very hard. So static members live almost forever. Static members, that's why static members should be avoided. And okay, if you still cannot avoid having static, please don't make it mutable static. So if it's an array or a list, it's in the future you'll have some memory bomb. Then, if your static members, they should not be updated from non-static field. And to avoid all these problems, we actually have some rules in Sonar, which one is one rule about mutable fields should be public static, and instance methods should not write to static fields. We would like to add more rules to avoid all the possible memory leaks, but unfortunately, static analysis is also limited, so we cannot detect all the problems, but at least we can try to prevent some big problems. Okay, we analyzed. In this case, it was easy to analyze because we know that static is a problem, so we found out the static and can easily fix it. Sometimes it's much harder to find the root cause, so let's look at some different example. So here, still we have similar situation. This byte array catches our attention because it holds a lot of memory. And then if we calculate GC roots, we can see that there is some names cache, but it's not static. So there is no problem in static. But let's look deeper. This byte array is value in some string, which is a content and stamp full name, and this is a key in a hash map. So this time hash map is used. I think that's not enough just to look in the visual VM, because in this case, just looking at the visual VM, I cannot say where is the problem, because I don't know what was the intention of programmer. So let's look at the code. So I think it was here, example controller. So here it is. This is a map. It's not static. And if you look attentively in the code, you can see that this name could be either A or B. And when we put some structure like full name into a hash map, we are using this full name depending on the name. If you go here, we can see that full name is just a class that holds two fields, name, content. We have getters, we have constructor, we have equals, hash code. So feels like it's okay. Feels like if we are here putting full name of A or full name of B into hash map, there should be just two instances. There should be just full name of A or full name of B. But for some reason, we have much more of them. And if you look more attentively at the full name class, we can find out that equals is written correctly, but hash code is returning the random number. So basically, if you know how hash map works, means that you calculate the hash code, then you find out in which bucket you should put it in a hash map, and then that's how hash map works. But in our case, hash code is always random, so we cannot find the already existing element, and we're already always adding a new element. So this is the problem. The problem is a bug in a hash code. So if we get back to our slides, that you can see that equals hash code are carbs, because they're great. You have to use it, and they're very important to use them correctly. Because if you're using carbs like sugar that are fastly go to your blood and transform into fat, that's not what we want. But if you're using carbs like vegetables, especially green vegetables, they give you much more energy to work. So for me, equals hash code are more like a carbs. But you have to use them wisely and choose which carbs to use. So first of all, they should be used properly. Then when you override equals, you should always override hash code, because if you just override equals but you had no hash code, you'll have default hash code, and the situation would be similar. And there is a contract that if two objects are equal, their hash code should be the same. And this contract is there for a reason. And one more important thing, that hash map keys must be immutable. If they're not immutable, you'll face exactly the same situation as we had. Because, again, you recalculate the hash code, and you're not going to find an element in the map. So we have some rules in Sonar for this, that when you override equals, you should always override hash code. Unfortunately, for now, we don't have a rule that if you're violating the contract or no, because it's kind of hard to detect. But we have this in our mind, so maybe one day we'll have this rule to help you understand if you are violating this contract or no. So once you found the root cause, what's the next step? The next obvious step is to fix it. So let's get back and find another example. Okay, here. Here, actually, this is the case when you look at the heap dump and you don't understand what's going on. Like, for example, I look here, the same byte array that I was doing in previous examples. I tried to calculate GC roots. And actually, I don't see what is the problem here, because there are some more standard classes, maybe coming from Spring Boot because it's Spring Boot application. So maybe I need something else. So what else can we do we can just try to find the projects, the classes that are in your packages to understand whether you can, how much memory actually is held by the classes that you wrote. And if I use com-example demo, which is my package, I can see that example controller 3 is holding like 2 gigabytes of memory. So you can see that we are using retained memory, not the actual size of a pointer, because retained memory means how much memory you could free if this object is garbage collected. So if this controller is garbage collected, we'll free 2 gigabytes of memory, which is a lot. So probably there is some problem here. So what we can do, we can investigate what actually is taking too much memory here. We can look at some fields. We see that there is field small objects, which is an array, and there are 32 elements, and they hold like 99% of the memory that is retained by example controller 3. And if you look at these small objects, you can go and see some elements. And you can see the biggest amount of memory is held by this $0, which is big object. And if you look at the small object here, it's big object, $small object. And what does it say to us? It says to us that small object is an inner class of big object. And this holds a reference to big object. So this is non-static class inside of another class. And if we go and look in code, we can see that it is. So there is small object that has almost no fields. It doesn't use anything from big object, but is non-static. And in order to create it, you need to create new big object and new small object. When you just look at this code, it feels like new big object is created only here, and then we never use it, so it should be garbage collected. But because this object holds a reference to the big object, it cannot be garbage collected, and that's why you can still find this in memory. And yeah, the obvious solution would be to make it static. Make it static and then refactor it. So yeah, inner classes, they should be static. In most cases, you don't need non-static classes. If you still need them, like, you should take care and understand that you hold the reference to outer class, and this outer class might not be very big, and the life cycle of this small object and big object should not be very long. So if you are using non-static inner classes, you should understand what is the cost and what you are doing. And in Sonar, we also have a rule that if your inner class doesn't use the properties of functions from your outer class, it should be static. So, and in most cases, this is enough. And another demo that I want to show you, I think it's the last one. This is another heap dump. You can see again that here we have byte array that takes almost all of the memory. And if we look here and calculate GC roots, we can find out that there is somehow a reference in thread local. So we can go and find it in code that we have indeed thread local here. We set some value, but we never remove it. Why is it the problem? Thread locals live the same amount of time as the thread lives. So when you create a thread, you put thread local there. Once your thread disappears, your thread local also disappears. The problem is, I am not creating threads directly in my code. I am using Spring, and every request is actually executed in their own thread, and it's in a thread pool. So I'm using a thread pool, and that's why we are using the same threads. And it means if you left something in thread local, it will be there unless you clean it. And that's why it's important to always clean thread locals, especially if you're using thread pools. So Yeah. Another potential problem with your memory are thread locals. Because they live as long as the thread lives, they should be unset manually. And the same comes with the resources. So if you're using some resources, some put-output streams, you should free resources as well. Yeah, you should free resources as well. And we have another few rules about this in Sonar. So the thread locals should be cleaned up, and resources should be closed. OK, we fixed our memory leaks, find all the root causes. What is the next step? The next step is to improve. What I'm talking about, let's go an extra mile. Previously, we were talking about memory leaks. Memory leaks, we refer to the situation when we are already having some problem, when something is using excess amount of memory, and we have to get rid of this. So technically, when you're overweight and you already have some health issues. So it's hard for your health, hard for you to run, to walk, to live. So you need some immediate treatment. It's more about firefighting. When we are talking about memory footprint, it's a little bit different. So memory footprint refers to the amount of memory that you are using. So reducing the memory footprint is more about when you're already in a good shape, when you're already in a normal condition, but you want to improve a little bit. You want more muscles, you want less fat, you want to be stronger. So this is about reducing memory footprint. Fixing memory leaks, it's more firefighting, and reducing memory footprint is more about making yourself more fit while you're already good enough. So what we can do to reduce memory footprint? First of all, let's remove references manually. If you don't need something, just put nulls. Feels like a little bit of C++ program. Another point, it could be custom class loaders. When we talked about statics, we discovered that they live forever. What we can do with this? We can write some custom class loader. So if we write it, we can control the life cycle of this class loader. And that's why we can be sure that some static fields of these classes are garbage collected. Another thing that we can do is to minimize the living scope of your objects. So if you don't need it, remove it. So put it as close to the usage as possible. Instead of some global variables, instead of some fields, prefer local variables because they cleaned faster. And yeah, do all the necessary cleanup. If your object holds some state and you don't need the state anymore, clean this up. And another possible technique that you can do is to use weak references. For example, there could be situations when you don't care and the creation of the object is not that expensive, but holding it in the memory is very expensive. So it's easier for you to tell garbage collectors that you can collect this reference if you don't need it, and then if you need it again, you'll recreate it. But there is one thing that you should remember. While you're reducing memory footprint, you should find some balance, because balance is the key. Sometimes when you're losing too much weight, or you're using too much muscles, and for example, when I lost too much, it was harder for me to lift some heavy weight. And the same for your application. If you are always cleaning up, if you have a lot of custom class loaders, and you recreating and using weak references, it affects your performance. Because if you need this object again, you have to manually recreate it. If you need to load this class again, it takes time, so it comes with some performance cost. So you need to find the balance to understand what is the right choice for your application, because there is no silver bullet here. So we improved our application. We already fixed our memory leaks. We improved it. What the last and the most important step to do is to prevent. Let's take some measures that will to make sure that memory leak won't appear again, or at least won't appear again in exactly the same place. So what we can do? Remember how it all started. It all started from Alexei Shepilov saying that I cannot analyze it with 3 gigabytes of RAM. So what was actually the problem? If we look about in the way how we execute the analysis, we have a list of plugins, like C++ plugin, Java plugin, Kotlin plugin, Scala plugin, and they're like in a list. And in this list, we are iterating over them with for each and execute it. And the problem was like Java was executed first. It ate almost all the memory because there was a memory leak here. Then C++ had to execute their analysis and cannot. So one thing that could help us to prevent this memory leak from affecting our users could be like reduce the life of plugin. And for example, let's use the queue instead of list. So if there was a queue instead of list, we would just poll. And once like Java plugin is executed, it's garbage collected, and then we can use like C++ plugin without all this garbage that Java left in the memory. But on the one hand, it could mask the problem. On the other hand, our users would have much better user experience. And what we can else do is to do some cleanup between the plugins. For example, remove some references that are still referenced in Java. And this way, we'll reduce some memory. So this would probably look like this if we would use array instead of a list. And here are a few small tips what we can do to prevent potential leaks. Firstly, follow healthy diet. I'll tell you in the summary of this talk what is a healthy diet for your application. Then, like, monitor memory usage. Like, from time to time, look at how much memory you're using before there is any problem. Try to, like, look at this beforehand before you have any problem. Look at GC logs. Perform some stress testing, or for example, in our case, we can try to execute analysis on some unusual inputs on some bigger projects like OpenJDK, like other compilers, and maybe we'll find out much more places where we have problems. And use tools like Visual VM, like Eclipse Memory Analyzer, maybe Flight Recorder. And another thing that we can do is to add tests. Like somewhere in the beginning, I told you that there is a tool called Java Object Layout that can show you how much memory, what is actually a layout of some objects in your memory, or layout of classes and even VMs. So with this tool, you can actually write some sort of a test. For example, you remember that this big object caused some big trouble previously. So add an assertion, say that this object should not hold that much memory, and for example, put a max size there. So if you eventually, if you're developing and one day you exceed this max size, this test will fail, and you'll have to investigate. Is it failed because you just naturally, or maybe you introduced another leak? Of course, it won't save like you every time, but at least some cases can detect. So this is the healthy diet. Just to say it again, avoid statics and mutability, clean thread locals, free resources, avoid non-static inner classes. If still need something of this list, be careful, reduce the scope of references, and do monitoring. And yeah, I was telling you about this story with Alexei, so let's sum up how the story ended. By the way, maybe last question, please raise your hands if you think that the story ended successfully. And not successfully. And what other things? Okay, the story ended happily, so we had a happy ending. Alexei posted a tweet that some time ago he moved Sonar Cloud to some smaller machines and he got out of memory with 3 gigabytes of heap. Then we fixed these memory leaks, and now it's less than 1.2 gigabytes of RAM. So Alexei is very happy. We are very happy because we don't have any memory leak. And because of valuable contributions that Alexei did by reporting these memory leaks, we sent him a t-shirt that he is our community hero. And this is very important. If you ever face any problems with Sonar and you're using our community forum, if you're doing valuable contributions, we recognize it and we send t-shirts. So don't forget to be active community members, because you're not only going to improve your life, you're going to improve life of your colleagues all over the world, and you might get this nice t-shirt. So here are some useful links that you can use, that I used while preparing this presentation. Thank you for coming, for your attention, for being here, and questions. Any questions? Everything was clear. Yeah, so maybe we can take some group picture while you're still here. So I can show to my colleagues that a few people came to listen about memory. Like, say cheers. Okay, tag yourself in my Twitter.
All right. So I'd like to welcome our next speaker on stage, Ron. Ron is a really experienced developer, and he'll talk to us about data-oriented programming in Java.
Very good. Yes, thank you very much. Oh, yeah. Ah, right, there we started. Yes, thank you very much for being here. Short introduction about myself. I'm a Java developer for 20-something years. I work at this company called Team Rockstars IT, where we are like a special agent, which basically means you do your normal consultancy work, and if you have any free time left, you can spend it on going to conferences and talk. So that's what I like to do, and if there's even more free time left, I'm writing together with a colleague a book on migrating cloud native Jakarta EE, so from Java EE to Jakarta EE. But today is a totally different story. It is about data-oriented programming, and it's not a new paradigm. It's not a paradigm specifically to the Java language, but it is something that is actually coming to Java, so it might be really interesting to know something about it. The first part is going to be just evolution of how we normally develop our applications, or how we used to develop them, and how they evolved. The second part would be a generic introduction to data-oriented programming. So again, not specific Java, but just the principles. Part 3, we're going to look at how does Java support these new, this paradigm. How does it support it? Because there have been a lot of new features added to Java language in recent years. So we're going to have a look at those, because in the final part, we're going to look at some examples of code, how we can actually, write this data-oriented code. Right? Starting the evolution of an application. So this is meet Victor. Victor, he's an application developer, and he works as an in-house developer at a company. And Victor is a happy developer because Victor works on timesheets. Now we all know timesheets, right? We all have to do timesheets. If you're really lucky, you probably only have to enter them once a month. If you're really unlucky, then you have to do it on a weekly or even daily basis. So timesheets, and Victor develops this application internally. Then it's a simple application. You got a timesheet header, there's a user attached to it, there's timesheet details with projects and activities. So nothing very fancy. And soon Victor will find out, because then the project manager comes one day and says, listen Victor, something must be wrong in the system, because I had someone who wasn't even attached to one of my projects actually register hours to my project. And Victor thinks, that's weird. And he looks at the code and he finds, yep, that can actually be. Any user can book on any project. So Victor comes up with a smart solution, and he enters something in between so he can actually combine and authorize which users are allowed for which projects. Life goes on, and Victor seems to be happy, and the company seems to be happy. But then the project manager one day drops in again and says, what is this? I have this project doing some API redesign, and I got some front-end guy who's actually writing activities, creating a new UI design. That can't be. And Victor looks at the code again, and the same story. So our system evolves, doesn't it? And not only the system evolves, but the company evolves. So more and more people are coming. And when we get bigger companies, then we get more managers. No one wants it, but it happens. So suddenly from a regular user, we also get the project manager as a role. We get to see the approver. So the system grows and grows. And then things really peak, and we're gonna go multi-organization, so multiple companies can use the software. And this is basically what happens, right? This is how our systems evolve over time. And we add new classes, and we add new functionality. And then if we look at the code at some point, it will probably look something like this. Now, this could be an enterprise Java bean or whatever. Doesn't really matter. But what we see, we use encapsulation. We got object state, and we got methods that perform operations on that state. And here's a good example. If a user fails to log on correctly, then probably the method, let's see, register failed login will be called at the bottom. And basically what it does, it checks, okay, have we surpassed a threshold? And if so, we're gonna change the state of the object, and we're gonna set the user to deactive. So we have these situations where we have code and data mixed together. And it always used to make sense, because that is how we created our large applications. Yet, these are the classical, what we now call monolithic applications. But I'm quite sure you've all noticed that there's a tendency in software engineering these days that we go more towards services instead of larger applications. So this typical application could be easily broken down into several independent services that have some kind of intercommunication. Typically, we would use something like domain-driven design. Currently, there's the workshop from Ottavio going on, where we could say, oh, wait, we got a user domain. And that contains these classes. And we could have a timesheet domain, and the core data domain, and then there could be something like authorization on the side as well. So we basically, and that's the tendency we see right now in software engineering, we're decomposing the monolithic application into smaller surfaces. And then we get into the realm of where data-oriented programming would actually be applicable, because suddenly you don't have the need anymore for these large object structures where you like compose all kinds of objects, but suddenly you can do things in a different way. So let's have a look at the 4 principles of data-oriented programming. Again, these are the generic principles. Java will have their own set, because we're not going to use them all in Java. Data-oriented programming, it became very popular, and this was the article that really kicked it all off. There was, it's about a year ago, and then Brian Gadsden, he's like the chief language architect for the Java language at Oracle. He wrote this article, Data-Oriented Programming in Java. It's on InfoQ, you can find it there. It's a really great article, and he explains how we can do things in a different way. And since then, Java has given it a lot of attention. The Java podcast, the newscast, actually had a series about it. And last year at Java 1, Gavin Bierman, he's also one of the advisors to the Java team, he had a presentation about data-oriented programming. So what are these principles? We're going to look at them first, and then we'll dive into some details. The first one is very simple. You should separate data and logic. The second one is you should store data in generic data structures. The data should be immutable, and the data schema should be separated from data representation. Okay, let's dive into each of these to see what is actually meant. And still, we're getting to the code part a bit later, so just bear with me. So, separating state from logic. So, the idea is basically you have your code here and your data there. So your data is in a separate class. So there's no longer this idea of encapsulation. But they're 2 separate entities, they're 2 separate groups of classes, behavior and data. Well, one of the advantages could be that code could be reused in a different context. Before we saw some code where we said, okay, if a regular user, if he fails to log on, then his account will be disabled. Now, that might probably also be applicable to the manager, the project manager, or to the approver. Now, there's two ways of achieving that. The bad way would be, of course, duplicating the code in a separate classes. That wouldn't be a good solution. We would probably choose to have an abstract superclass where we had this functionality and the other ones would then inherit it. An alternative would be a data-oriented approach, is say, no, let's just separate the two. I mean, I am passing a user object, which could be any of these three types, and I'm passing it to a method where it should validate. And it is not that strange. We'll get to that a bit later. You might now think, that sounds not good. But I'll bet I can convince you that it's actually something you might be doing already right now. So testing in isolation. If you have code and data in one object, then it's just really harder to create these objects and to initialize them properly for testing. If you have them separately, it makes it much easier. It tends to lead to less complicated systems, basically because this whole hierarchy of classes, that it's like being broken apart into two separate layers. Data should be stored in generic data structures. That was the second principle, right? So what are these generic data structures? Well, there would be lists or queues or maps. So we have these things in Java, so technically we could use them. That's the whole idea. And there's a reason for that, because it allows for a flexible data model. If you would want to add a new field to one of these data structures, it would be really easy, right? If it would be a map, you could really have a key value thing. The key could be the name of the field, and of course the value field would be the value it would hold. So it allows you to quickly react to changes. In general, it says, okay, you can also use generic functions. If my data structure is not a user class, which is very much typed to a certain type, but it's a map, then of course there's much more functions you could apply to maps. The data should be immutable. Now, immutable doesn't mean we can never change the data, right? But it is still, the reference to the data may change, but the underlying actual values, they can never change. That's the important thing. So if you want to change something, you should just return a new object, which is the reference, with the new values. This gives predictable behavior, and the idea is, if you have this program here from A to Z, and any of these places you can change your code. If there's going to be some code, data change, and if that data changes is not according to what you expected, it's really hard to find where it is. But if you have defined specific places, it shouldn't be that much of a problem. And of course, immutable values enable safe concurrency. If any of my threads accessing an object is not changing the objects, then I can never have any erase conditions. So there's never any problems there with concurrency. Right. The last one is maybe like the most unclear. It is separating data schema from data representation. But think untyped languages. Think JavaScript. You can have a variable there where its type is not clear up front what type it will be, or it's not defined. So this is all about expressing how to shape your data. Or think XML. XML is still data, right? So if we have XML, we would use an XSD to describe what type each of these fields are, and also what values are possible, if it is a mandatory field or not. And we could do something similar, for instance, with JSON schema. So those are the principles. So let's see what has been added to Java so that we can support these data-oriented programmings. Now, if we're saying modern Java, I'm talking Java 17 to, well, 21 is almost there, right, in September, so 17 to 20. Is anyone here working with 17 or higher? Ooh, okay, that's already quite a lot of hands. That's very good to see. We're going to look at a few things in specific. We're going to look at the records, sealed classes, pattern matching, and switch functions for pattern matching. So it's going to be interesting to see how familiar we are with things. Records. Who knows records? Ah, that is so good to see. So many know it. I'll just give a short introduction then to records. Records are actually, well, they're transparent data carriers. You have data somewhere in your in your application, and you want to pass it around to different parts of your system. This is how you define a record, and this is all you need to do to define a record. A record is just not a class, and as you can see already in the definition, you are defining the name of the instance variables which make part of a record. And these instance variables, they're final instance variables. And we all know what that means. Once the constructor completes, the fields have their final value and they can't be changed anymore. So here I'm basically saying, okay, I got a record and it has 2 strings for email and password. It has a Boolean variable to indicate whether the account is blocked. And it has a counter how many login attempts are there. Just by writing this, so I have these 4 instance variables. I have kind of getter methods to get the values out again. I got, of course, the equals, the hash code is overwritten, there's a constructor made for me, all this code just with this one line. If I want to retrieve any of the values, well, sorry, this is how we actually create it. It's just like you would create a normal class. You know, we're using the var keyword here because the compiler can do type inference. So he knows, okay, user will be a user record. You just provide all the values, and you got yourself a brand new record. If you want to retrieve the value of the email field, you can write it like this. So no more getter, setter, this Java bean convention thing. Well, setters weren't there anyway because they're immutable, but the getters. But we can just refer to the name of the field and retrieve the value for it. That's nice. But it comes with something extra, which are called compact constructors, which you basically can write like this. What you're telling here is that you're saying, okay, I got a user record, and this is my constructor, but you're not specifying any of the fields, because the compiler says, listen, mate, I know which field you're having because you defined them up there. You don't have to tell me again. And in this way, you can still do all your validations of the values coming in. So if I'm referring on the first line to the require non-null of an email, I'm actually referring to the parameter value and not to the instance variable. Actually, if you look at it, I'm not setting any values here because I'm not setting the instance variables. The compiler will take care of that for me. Great, those are records. Immutable data carriers. You can already see where this is going in respect to data-oriented programming. Right, sealed classes. Sealed classes were added to Java for a reason, because if you define a class in Java, let's say you define a well, basically you're creating a public class. That's the option you have in Java, isn't it? If you look at it at either you make your class public and technically anyone can inherit from it, or you decide to make it final, like for instance a string class that no one can inherit, and you really don't have, well, you can do a little bit with access modifiers, but in general those are the 2 flavors you have in Java. Either everyone can access it or no one can. Well, income sealed classes, because with sealed classes, you have the ability to say, nah, I'm going to determine myself who's allowed to inherit from me. And everywhere where I say sealed classes, the same applies to sealed interfaces. So this is a sealed interface. We had these 3 types of users before, right? So I'm now saying, okay, this interface user, there's only 3 subtypes that are allowed to inherit from me. Approver, project manager, and a regular user. And that means that if any other class tries to implement this interface, it will say, no, not allowed. The compiler will complain. So suddenly you have complete control of who is allowed to inherit from your data. So, but each of these classes mentioned here, because we have the sealed interface and then it says blah, permits. So all the classes after the permits clause, they have to tell themselves again how they are going to handle inheritance. And there's 3 possible options. Like, the easiest one is that approver in this case says, you know what, I'll permit timesheet approve and invoice approver. He does the same like the main class. The second option is project manager. We just said we already have too many projects, managers, or managers in general, so we're going to make this class final. That's the second option. No one can inherit from project manager. And there's a third option, which is the non-sealed class. And basically what non-sealed here is saying is, you know, I don't care anymore. Anyone can inherit from me. So completely fine with me. I don't have any secrets. You may all inherit from me. And though it may seem that suddenly you're throwing away your carefully crafted object inheritance strategy out of the window, it isn't really like that, because anyone inheriting from regular user will always be of that type. So even if I have 10 different types, they always will have the same super type. So, sealed classes. And then the third part that we need is pattern matching. Now, what is pattern matching? Pattern matching was added in Java 17 carefully. And pattern matching is all about having a predicate, a test, an object where you apply this predicate to. And if the test is successful, then we can extract one or more pattern variables. And these pattern variables will be in flow scope. So let's look at an example. We have this line here, and it says, return user is an instance of approver A. And this may look a bit like, oh, but wait a minute, instance of has already been in Java like forever, right? But this is the instance of pattern matching, so it's a bit different. You might notice a little A there behind approver, which is not in your normal instance of. So in this situation, the predicate, instance of, is the predicate. So that is the test we're going to apply to user, which is the object to test. And if this test is successful, then we have a pattern variable will be created, A, and basically user is then the casted instance of approver. So it's cast to approver now, so I can make it behave like it is approver. And the flow scope basically means that between the brackets A exists, and as soon as we get to the end of the brackets, A no longer exists. Great. Next thing they did was add pattern matching to switch. And we all know switch, right? We always had the switch statement. And then later with Java, we got the switch expressions, where we suddenly could do different things, and switch suddenly became kind of functions, and they returned values. Well, Java has something like this now too. It says here, I'm getting in a user, and it should just return me if this is an approver, or a project manager or a regular user. So I'm actually testing here for the class type. And the type suddenly becomes kind of a value to your code, because it says, well, if it is like this, then please return true. So if approver, I'm still having the pattern variable a then, not using it, but it'll still be there, and I'm returning a value. So it now is testing against class types, and not where Switch would normally do, test against values. So that's why we say that actually Switch has been lifted, and data is now has become values. So you can have data objects, and they are just normal values. So we can also write desi, because there's a second line in here where we say, hey, approver. This is called a guarded pattern, where we can say, oh, if it is an approver, that's great, but I only want to return true for approvers if the approver is still active. Otherwise, I can't show them in a list of active approvers. And then you can see there's actually another line with approver, just without the when. The whole idea about pattern matching with Switch here is that the compiler can reason about exhaustiveness. If you would have a normal Switch situation where you say integer, case 1, case 2, case 3, you always have to do a default as well, right? Because it might not lead to one of these, and it can't do anything. So it has to know what to do when it is not 1, 2, or 3. Well, here the compiler actually knows. It says, oh, you're giving me a user, but there's like only 4 types that can implement a user, 3 types. 3 types that can implement a user. So it can really check for those 3 types. Now, I needed to add the second line here because the first one actually excludes part of it, right? It excludes the approvers that are not active, so they have to be caught by the second case. Java didn't stop there. We had records, and then it thought, we're going to do record pattern matching. And that consists of 2 parts. First of all, this very simple part. If the user is an instance of a user record, apparently we can now use a user record there as well. We're going to name it UR. UR is now a user record, and I can call a method on it right away. The second part is perhaps even more interesting. Look at this switch statement. Okay, there's a few things in there which are really new. First of all, okay, we're getting this record and we're saying, if it's a case null, before you could never do this. You always had to check before your switch, when you use the switch statement, to check if the value in your switch statement wasn't null. If it was null and you didn't check, you would get a null pointer exception. The Java language designers said, okay, that's not a good thing, so we'll switch around and we'll put that in as a valid value. But then the second case, user record, and then it says string, boolean, int. Anyone has any idea what is going on here? That man in the end. Oh, you're brilliant and stealing my show. That is actually correct. We're destructuring the record here. So it seems like we're saying again, oh, wait a minute, I have to define a user record with the same structure and the same signature again? Well, that doesn't make sense. But actually what is happening here is that we're saying, oh, could you please take it, if it is a user record, could you please take it and then assign the email address to the field E, the password to P, and so on for the Boolean and the number of attempts. So it is destructuring the record. Instead of a constructor where you apply individual values and create an object, now we're taking an object and pulling them into individual fields. So that is really a very powerful construct. A little change which was added to Java 20 is that you no longer have to tell now to the compiler that it was a string, boolean, integer, because the compiler says, well, I mean, you say user record, I can look it up myself and I know what these types are, so I'll just tell var, so you can use them. And in Java 21, there's going to be an additional feature where you say, you know what, I don't really care about the third and the fourth field. You can just put an underscore there, and then the compiler, you'll tell the compiler, ignore these values, and he won't do it. So that makes it even more readable. That's actually really nice. This is a bit of a special thing because they said, you know, we have this enhanced for loop, right? For, and then you could loop over a collection like here. So you're getting a list of users, and then you can loop over it, and you can do the destructuring inside of the for loop. And this is a bit of a special case because this will only be available in Java 20. It was added in Java 20. It will be removed again in Java 21 for reasons unknown to me, but I thought, we might bring it back in the future, but not now. Great. And of course, here you can use the same thing where you don't specify the specific types, but use var instead. Right. Finally, we got to the part where the code really comes. So, combining Java and data-oriented programming. Let's do a quick recap, because we said separate data from logic, right? Well, is that really strange, separating data from logic? First of all, you could do it with static methods, because static methods, you know, they're great. They're great to use, and you can just pass them a class. They can work in it. You don't need to create objects, so that could be really good. And for anyone who was at a session here before, static data fields are bad, but static methods definitely are not bad. And if you think about it, I mean, I guess a lot of you, who's using Spring here, Spring Framework? Right, many hands. Aren't you using kind of like already splitting data and functions in Spring? Because all your code is normally like what, a Spring Bean, some add service annotation that you will inject somewhere, and if you call a method on it, you'll probably pass it the data. So it isn't that strange. And for all the other ones that were using still AGBs or something else on JEE, basically you're doing the same there. If you think about it, there's this annotation stateless within Java EE already, where you're kind of saying, you know, this doesn't hold any data. So it is not that strange an idea. Data should be stored in generic data structures. Oh yeah, well, we can do that in Java, right? Java 9 gave us these great methods. So instead of this user record, we could like make it in a map, key value objects and stuff like that. And then we could actually retrieve the values. It's not really pretty. And I think we just found with the records that we have a way better way of using a kind of generic data structure. Of course, you still have to define it, but it is especially meant for that. The data should be immutable. Well, that's easy because we just said records are immutable, so that comes in really handy. And the data schema should be separated from representation. I mean that would be crazy, right? If we would just use these key value types and stuff like that, because Java gave us compile time type safety. It will check for us if we're using, if we're not using two uppercase on an integer object. So it would be crazy to throw that out. So basically, we are left with these two options: separate data from logic, and the data should be immutable. So let's look at an example. We all know the Java optional class added in Java 8, and basically you have a variable, and might be null, might not be null. You're not really sure. It's a kind of Schrödinger's cat situation. Until you look into it, you will find out if it's either null or not null. So why not wrap it into this optional class? And if you have this optional class, then basically you can ask it via is optional or later if optional, and provide a method to see if this data is actually, if it is null or not, and then act upon it. Brian Getz, the language architect, he said, well, if we had records and sealed classes and pattern matching when we had Java 8, probably we would have written it like this. And what we're saying here is, okay, we have an interface, opt, which is a generic interface. It's a generic type, so it could be any type. And it only has two possible values that are allowed. It's either sum with a value that's in there, or it is none. Right? Now, if we would look at an example of this code, take this class. We're saying, okay, a class that takes in some parameters and it calls the run method. And the run method, there's two things. It calls a validate on these arguments. And if the validate, and it passes that value on to the process method. Well, the validate is a string, takes a string array of arguments, and the processor takes this obst again. Now, if we look at the implementation then, this would be how the validate would work. It just checks, okay, are there any arguments? If there's none, it will return an obst none, right? So because no argument, so there's nothing to return. And if there's something, it will take the first command line argument and create an instance with obst sum. And that means that in the processing code, the process there, it can really reason about it because it now knows that whatever it is getting can only ever have two possible values. Either something is, it is sum, and then some value is in there, or it is none, and then you can just simply ignore the value that is in there. So basically what you now have done is, these are the only two possible values. Any other invalid state has been ruled out. One of these is the only possible solution. So what it means is that we're modeling the data as data because we now are really reasoning about the data as if it was a number with a value. You know, we're reasoning about the value. The data is still immutable. We should validate at the boundary. If we're having, like, let's say, you have some JSON web service, so it's a web service, it has a method, it takes in a JSON payload. Probably that's the first place where you want to check. So your first check would probably be check if the JSON is valid. If the JSON is valid, you're creating your records, where we just saw that in the compact constructor you can add your validations. So that is validating at the border, and then make illegal states unrepresentable. It was some or none, but can't be anything else. So let's look at one final example. Say we have this REST resource. Well, it's a normal class, right? It has a data service, which is final, and it probably gets injected via the constructor. And it has two methods. It has a get to search for values, and it has a post for creating some values. Now, if we would look at the search first, if we're going to search for a value, say we're searching for something, it could technically have three possible values, right? We could find nothing, because we just searched for a really weird term. If we search for the primary key, like a customer number, we're probably getting one returned result, or we could have multiple values. If we're searching for a name, we're probably getting multiple results. So if we would model this, we could make a sealed interface like this, where we're saying, okay, sealed interface could be of any type, could be user, could be product, whatever. And there's a few possibilities. No result, an exact result, in that case we're specifying the result, or it could have a multi-result because we searched for a name and then we get a list as a result. Now, if you would have the search method, it would actually say, okay, this is the example code and we're just returning an exact result. But it's basically how your search method, if it would react upon these things and create things. And then your remaining code could really look like this. You've got the search method. It takes in a value. You're calling the service find projects, and you know that find projects will only ever return one of three possible values, right? It would be the no result, the exact result, or the multi-result. So your code is completely clean. Again, you're taking actions upon the code and upon the values, and your code is very clean. And actually, if you look at how it is, you could reuse this almost in all your endpoints then for searching. But no one can ever look at this and say, I have no idea what happens when we have got multiple results. So the code is actually very, very clear. Going back to the other part, where we say, okay, we also have this post method, the create. So this create method, it has this master data source, right? So it gets an object master data, it does a validate, and if the data is valid, it will be stored. Now, master data could again, have an interface and say, okay, I'm permitting project, activity, sub-activity. A bit different here now. Before we defined everything inside the sealed interface, you can still define it like this way, where you say, okay, a record implements master data. So that's another way of describing it. The other way with none and some, that was really nice together. But if it's really like a long list of information, then this would be a better way to model it. So we have these 3 possible subclasses. And then we have the validate method. And the validate method would again be the same. Okay, say this data came from this JSON interface, right? So the data comes in, you're gonna validate it. If the JSON is crap, then you probably get a null in master data already. And then you can simply say, okay, if it's null, validation will fail. And otherwise, it will determine again, okay, what type of object did I get? And based on the type of the object, it can call the correct validation method, which makes again really clean. It is really almost like if you say case 1, 2, 3, only now you're talking about object types. But object types have become a first-class citizen in this way. So you can do your proper validations. And now we know that the validate method will always return either true or false. So the store method to store the information doesn't have to reason about being null anymore. So it can just, again, do its thing, but again, based on type of class. So that makes it very easy to reason about your code, makes it very easy to follow. One could say, okay, if we get like another new type next to project activity, sub-activity, that means a whole lot of rewriting my code, which is correct. But the good thing is the compiler will tell you in every spot, listen mate, we had this hierarchy here where we defined a sealed class, you specified 4 types, you're implementing only 3, could you please come here and fix it? So the compiler will really help you there. So, as a summary, data-oriented programming treats data as first-class citizens. It reasons about the data as it reasons about strings or integers that we have. It looks at their values. In that case, the data drives your application, because we saw that depending on which type they are, we're going in different parts of our application. So that is really how the flow is going. Well, Java supports data-oriented programming via records, sealed classes, and pattern matching. Any questions? Oh, there's a question down there.
Thank you very much for the interesting talk. And my question is related to the idea of separating data and logic itself. Because all these points that you've shown are absolutely valid. I think that these are good approaches that you should apply in your code to make it more maintainable. But if we are working with a regular, let's say a regular Java application, like an enterprise one, if you separate data, if you separate logic from the entity, so it would make probably that your whole logic is spread across the whole application. I've seen this several times. I understand that if you are working with data transfer or data enrichment, because I work in big data department, we have many such services. When you read from input and write to some sink and there are some transformations, then okay, that's totally fine. But if I have complex business logic, do I really want to separate it from the entity? So that's my question.
Do I really want to separate the data from the entity?
Separate logic from the
logic,
entity.
the logic, exactly, the business logic. Again, I asked before, good question by the way, because that is one of the especially to Java developers, object-oriented developers, it doesn't feel natural to have static methods where we do things, right? It doesn't feel very good because we have been trained to make everything an object. And so that's why we normally would like to have objects, and we have learned about encapsulation. So we have data and we have methods performing on this data. But like I asked before, who is using Spring? If you use Spring, again, I think we are already doing that in large parts of our application, because if you have your Spring Bean, it will very unlikely contain state, because the state will be somewhere else. Of course, you can still have an entity object, and I'm not proposing to say, okay, we have an entity object like the at entity, so the thing we're reading from the database, the JPA entity, and saying, oh, there should be no logic in there at all. But I think already when we started adopting the repository pattern instead of the active record pattern, we decided to move a lot of behavior to a different class, right? Because active record would basically be capable of saving itself, retrieving itself, and with the repository pattern that Spring actually proposed, it already has been moved to a repository class. This doesn't have the state. So the answer is, it depends. Sometimes, that's always the best answer, isn't it? No, but it's true, really. Sometimes you want to do it, sometimes you can't. One thing is for sure, records, I didn't mention that before, but records can't be used with JPA, because, you know, JPA describes you should have a no argument constructor, so zero argument constructor, which contradicts with records, because records require all the arguments to be there.
Yeah, speaking of static methods, they are not polymorphic. So if I make a database call in a static method, or I'm reading from file, or I make an HTTP call, I cannot stop this, I cannot mock this. So maybe it's better to make an interface with several implementations instead of static method.
That is definitely true, depending, especially if you would go to the database, yes, then I would definitely, if you would do any kind of potentially blocking operation, I would definitely choose something like that. And that's why it doesn't mean that data-oriented programming means kick out all your objects. You never have to use objects and classes anymore. That's not it. It can perfectly go together. Data-oriented programming can work very fine with object-oriented programming. And in fact, all the ones here loving functional programming, there's a lot of, you know, paradigms in there that from functional programming that you can see in data-oriented programming. Thanks for your question.
Thank you.
Are there any more questions? And if not, then thank you very much for your attention and enjoy the conference.
All right, so welcome our next speaker on stage, Horace Jr. He's a senior developer evangelist at Oracle. And today he'll reveal how we can revolutionize Java database application development with reactive streams and virtual threads. So, Horace, you have the word.
Thank you very much. Hi, everyone. Yes, my name is Juarez Barbosa Jr. I'm Brazilian, but currently I live in Dublin, Ireland. And I work for Oracle as a senior principal Java developer evangelist. And today I'm here to talk about Java app development with reactive strings and virtual threads. So without further ado, let's get started. This is our agenda. Talk a little bit about Java app dev with the Oracle database, so you can understand the benefits of using, for example, things like the Oracle JDBC driver and the database itself, of course. Support concerning the latest Java versions, overview of Oracle DB access with Java. There are several different libraries and options for you. All of them are quite powerful and interesting ones. Talk a little bit about JDBC using a kind of async and sync approach to data access. Of course, talk about the issues with the classic platform threads, perhaps as a good segue to Venkat's presentation this morning. Then explore, of course, Project Loom and virtual threads in the scope of JDBC. And all the related JAPs, the proposals that we have currently, including the latest one on 444 that sets the stage for releasing virtual threads in JDK 21. We have a quick demo, simple code, but it will perhaps really allow you to realize the benefits of using virtual threads when doing database development. Then explore, as I said, async and sync JDBC and all the options. There's a kind of a specific library provided by Oracle called RSI, Reactive Strings Ingestion, that allows you to use some specific features provided by the Oracle database that primarily bypass the SQL mechanisms and allow you to ingest data in a kind of optimized approach, and that's good for applications that has this requirement of ingesting data from sensors like IoT applications, smarter cities ones, and so on. Then explore another option, a library that we have with R2DBC, the reactive relational database connectivity. Several database providers have that, and Oracle has a very good library as well. With a quick demo with Project Reactor, but that can support many different reactive-related libraries. And then talk a little bit about other things that we can offer to developers, things like the workshops, live labs. By the way, we have a workshop tomorrow to explore a little bit about database development with Spring. And also talk about the Oracle Cloud and EA's program, okay? Which is quite interesting in case you want to become a kind of distinguished developer in the community. Oracle can support you. There are several different levels. So yeah, it's time to explore the talk and the topics here. So this is just to give you a glimpse of app dev with the Oracle database. You can see all the established frameworks here, and all the JVM-friendly languages like Kotlin, Scala, Java, of course. Things like Spring, RX Java for reactive programming, struts, there's still some kind of legacy struts-based applications running currently. But at the end of the day, with JDBC and another library and support that we have called UCP, the Universal Connection Pool, for frameworks like Spring, for example, when you connect to Spring, by default, as far as I remember, Hickory is the default connection pool, but you can also replace and use Apache DBCP. But of course, if Oracle is the target database, perhaps it makes sense for you to enable UCP, because the way that it operates against the database is, of course, optimized by Oracle as well. But the takeaway concerning this slide here is when you check and you see the Oracle database as we framed it here, you can see that we call it a converged database. Why? Because regardless of your data, the data that you want to store, for example, you can see here relational, spatial, NoSQL, graph, XML. It doesn't matter, you know. You don't have to run several different database engines. For example, perhaps you start a NoSQL database and create another single point of failure in your architecture, you know, because the Oracle database as a relational database management system, it can store all these data types, you know, and data formats. So that's why perhaps Oracle is a good solution. And, you know, there are many Java projects running currently, and they use the Oracle database. So this is something that I would like to highlight and emphasize here. Because Oracle can support things like NoSQL, for example. So you don't have to go and, I would say, as a requirement, consider a different database. Let's talk about the support concerning data access in JDBC and the latest Java versions. For example, Java 11, the current driver is compiled against and it supports natively Java 11, but it is also certified for Java 17. We try to follow, you know, the way that the releases are happening because this is important for us in terms of being able to implement and support features, you know, and with the new release cadence for Java, you know, years ago Java was somehow lagging, you know, and being behind some other, we can say, languages, you know, that are, for example, these are functional by default, but Java now has, you know, we support functional programming and virtual threads, you know, in comparison to coroutines, for example, that you have in Golang and so on. So Java is there with everything, and we try to provide you the best support we can concerning the JDBC driver, all the libraries that I'm going to talk about in a minute, and of course the JDBC driver, as I said. GraalVM, and interesting to say because you can use and combine the JDBC driver with GraalVM concerning things like native images and compilation and execution, you know. Interesting to say, as you know, GraalVM, depending on how you implement that, at the end of the day, you end up removing some classes that are not being used, you know, and somehow that can, of course, in terms of cybersecurity and security overall, reduce the surface attack of your application, and that's a good thing as well. JDBC standards, of course, we support the latest versions as well. The implementation is there for you. Reactive strings, you know, all the, I would say, wave that we've experienced concerning Java development, you know, with reactive programming, you know, event processing, all those things, and also messaging related applications and so on. We do have support for these libraries, and that's interesting because if you have, for example, you are using, I don't know, maybe Akka or Vertex or, you know, Project Reactor in other layers of your application, it does make sense to use that, you know, at the data access layer as well. So the support is there for you. Virtual threads, as I said, the driver then is compiled against it, you know, and it supports virtual threads because we are seeing now every day, you know, new projects and libraries and releases happening, you know, and announcements concerning support to virtual threads, and some libraries are being written to support that, but the Oracle driver is already ready for you, so you can start to use the driver as it is today. You know, you just go to the Maven site that we have, for example, and you download the driver, and that's it. And why data access is important, and I'm glad to see you here today, because at the end of the day, we know, right? And we have, for example, several different initiatives like the ones by the Jakarta AE organization, for example, supporting new implementations in terms of having data access support and new APIs and so on, because in case you have a problem, a bottleneck at the data layer, for example, that possibly can propagate and affect your other components and other layers, and at the end of the day, the end user can end up also perceiving some performance degradations, So this is something that you should never overlook, okay? It is really important to have the right strategy and approach to your data access layer as well. Yes, so this block diagram gives you an overview of all the options that we have. From the right-hand side to the left one, you can see here the Oracle JDBC driver, and it implements the Java SE reactive string interface, the Flow API, right? And you can see our red dotted and dashed rectangle here, comprising both the standard JDBC API, but also what we call the JDBC reactive extensions. So with a single jar, the Flow API is already there for you as a first step, perhaps, concerning this implementation to reactive programming. So you don't have, for example, to add any additional jars, for example, to have that supported in your application. The second option that we have is the R2DBC driver, okay? Reactive Relational Database Connectivity. As I said, this project started years ago as an initiative, as far as I remember, by a company called Pivotal, but several other drivers and database providers and some open source projects decided to support it. So there are plenty of other opportunities and drivers there for you. But concerning the Oracle database, we do have production-ready driver as well. We released version 1 of this driver months ago, so this is interesting to have a look. I have a quick demo here. Perhaps not the best option now, concerning that we have virtual threads, which is the thing that will really revolutionize the way that we can access data again, as you can remember from the title of my talk. Okay, and we can see at the bottom then, you can still do, of course, sync and blocking JDBC calls, but now you can combine JDBC calls with virtual threads, okay? Lightweight threads, and that's really, really good for you in terms of, I would say, leveraging in a better way your hardware and OS resources, everything, CPU, processor, disk, memory, So let's talk a little bit about the options concerning this async and sync database access. Project Loom, that's good because, possibly as Java developers, everyone here, is aware of what Project Loom can offer in terms of running lightweight threads, in comparison to the traditional classic platform threads, and the use of the logical threads, supported by Java now, as we can call them carrier threads, okay? But the combination, as I said, of JDBC with virtual threads now will really allow you to run queries in an optimized way. I have a quick demo here. The code is quite simple, but as I said, it allows you to realize how interesting that is, because I run the code from my laptop here. You will see a massive difference in terms of the number of OS threads that are created. So this is something that you should have a look, definitely. And in comparison with synchronous libraries, for example, the thing is that it is fantastic that we can perhaps revert to doing and use the same Java thread length API as we know it, and run and work with libraries that are based on the traditional Java thread model. Because, for example, if you consider all the Java-related tools, things like the JDK Flight Recorder, JConsole, and so on, they are all built, and they all consider the Java threading model as the base to allow you to debug the applications, for example. It is really difficult, depending on the library that you are using, to debug a reactive-based application, because you delegate the call to a number of different objects, so it is not always so evident or easy to really debug and understand which thread or which component is executing your call, okay? And that's the comparison with the reactive programming, as I said. We do support that, and personally, I'm not against a reactive programming. I think, there's no silver bullet in software development, of course. So you have to analyze your use case, if that's synchronous, and then really understand. And perhaps, as I said, your project is already using reactive libraries for other layers. So perhaps that is what will make sense for you to adopt and implement for the data access layer as well. In terms of availability, the driver, you can combine that with Reactor, RxJava, Akka, Vertex, and so on, but we'll see that as part of my demo later on. Platform threads, if you consider the platform threads in the scope of the database access, the traditional way of doing it, there are several different issues. For example, the one-to-one allocation, concerning the platform thread to the thread that will execute possibly your database operation, a SQL, so a select, for example, or any CRUD operation, for example, create, read, update, and delete, right? Performance degradation, the use of the processor time, memory allocation that might affect your memory usage as well, and possibly, depending on how massive your application is, you have to really optimize your JVM. And even with the advancements concerning the Java collector algorithms, for example, this is something that you have to pay attention currently. But virtual threads will perhaps minimize, I can say eliminate, but I would say remove and alleviate this burden concerning your job as a developer. So yes, virtual threads, you can see the enhancement proposals here, 4.2.5, 4.3.6, and 4.4.4, okay? The first one as a preview, second one, second preview, and now the final one, 4.4.4, it is a proposal to finalize virtual threads as part of JDK 21. That's about to be released, and coming in September this year yet, so that's good news for us. And then, of course, it will simplify the way that you can, develop database operations. And the nice thing, I think that's really a fantastic job by the JCP and the thing that worked in the scope of the JAPs, for example, because the way they actually implemented virtual threads, they are not altering the Java concurrency model, and they are not disrupting the interface or the contract of the existing Java LangThread API, or even the executors, for example, because software, it is really easy for you to do something that is complex, Achieve complexity in software, we can do that easily, but it is really difficult for you to create something that can, I would say, address all the requirements, but keep, and then keep that simple in terms of the implementation and the way that you can deliver the desired functionality and then address all the requirements. And they achieved that. If you check the API for Java LangThread, for example, there are several, I would say, methods, no methods here, but all the existing ones are there, so you are not disrupting or perhaps breaking contracts concerning the previous implementations. You can see here, for example, methods that allow you to check if a thread is a virtual one, the builder methods, for example, and also start a virtual thread. Same thing with the executor. So considering all the changes that are happening, as a kind of implementation behind this interface and the contract and the actual implementation, as I said, I think that we should really praise the job that the guys who collaborated in the scope of these JAPs executed and achieved, okay? And we'll see that. Okay, so we'll have a quick demo now just to check and allow you, as I said, to realize how interesting is to actually revert to using virtual threads with database access and Java database development. Yes, the block diagram here you can see just to allow you to perhaps refresh your understanding of that. We have the OS threads, or the kernel threads, depending on the OS, and it doesn't matter. And then we have the Java platform threads, but in the scope of the virtual threads, we can call them carrier threads, okay? And on top of that, we'll have the virtual threads executing. So you don't have that one-to-one association anymore. And if you want to compile that, for example, there are several different switches for the Java compiler, and the Java interpreter as well that you can use. I have a Maven file here, by the way. I have a blog post about this demo here, along with some code samples that you can visit later if you want to reproduce that. So let's have a look at what I have here. Okay, so I have the implementation here is a simple one. As I said, there is no tricks here in terms of what we have. We just have a database config file just to retrieve the usual, URL, username, and password. A hard-coded query here. And then I just create 1,500 threads, but I'm using here a classic platform thread, okay? If you check then the task manager, I'm using Windows here, you will see that the number of threads here, 3,621 at the minute, okay? If I run this query here, and the query, if I go to the implementation method here, as I said, nothing specific here. Perhaps the only thing that I'm doing differently here is that I'm using the Oracle connection and data source, okay? But you can see that this is just a statement. I execute the query, I process the result set, and that's it, okay? But at the moment, you can see 3,600, let's say, threads here. Let's execute that, again, remember, with the classic platform threads, okay? And see how that performs. Okay, I can run it. You will see that there's actually possibly soon a spike. Yes, you saw from 3,600 threads, there's a spike, a sharp increase, and I have now 5,127 threads running here. Okay, so you can really see, and that's nothing because I'm just running a simple query, and that's my laptop. But if you consider that in the scope of perhaps a cloud-based application, receiving millions and millions of queries per second, massive applications, that's quite meaningful, okay? I can possibly, because it is stable now, I can stop it here. And the second example is as simple as the first one, okay? But the difference is that I start the threads now with virtual threads, okay? Possibly that is stable now, yes, it is back to 3,600 threads, okay? So I can just execute the one with virtual threads now. And that will allow you to confirm and really understand and realize the benefits of that. Okay, it started to execute. There's no spike, no sharp increase in the number of the underlying OS kernel threads, okay? Because we are using platform threads here. So remember, if you are deploying a cloud application and you have, I don't know, 2,000, 5,000, 10,000, 100,000 concurrent users running queries, that's really important because virtual threads will allow you to better leverage your hardware resources and perhaps optimize the return on investment on your cloud environments. So at the end of the day, you can reduce your costs and save money. So that's really important for everyone. All right, so that's the first code sample, a simple one, as I said. Let's go back to the presentation. Okay, and proceed here. Yes, so we talked about then platform threads and the association with the Oracle JDBC driver. Now you can see the synchronous JDBC calls as we performed here, with and without virtual threads. But of course, you can also use reactive programming and reactive strings in a non-blocking way, right? Blocking, you remember, when you have a request or you run something against a remote server, you are expecting a response at the same time, And asynchronous, it is a kind of fire and forget approach, You send the request and you forget about it, and possibly you can receive the response in a kind of callback or a handler that will handle the result for you, so you can process the results, right? So the first example here, this is specific to the Oracle database. So I'm not saying that this is something that you should use for all the applications you have, but in case you have an Oracle database as part of your solution, you should have a look at that. Why? Because this thing, the reactive strings ingestion library, it uses several internal components of the Oracle database on the database side. The most interesting one is number 4 here, what we call direct path insert. Okay, when you are using this one, let's say that you want to insert 1,000 records. You don't have to use the traditional standard SQL mechanisms for that, because internally this library will use the components of the Oracle database to actually bypass the SQL mechanisms and insert and use the native format for the Oracle database to insert all the records at once. Okay, so in combination with other features like rack, real application clusters, and the universal connection pool, as I said, right? This is good for applications, again, as I said, things like Internet of Things. You have perhaps thousands or millions of sensors, right? Or all the different streaming related applications that you can consider and think of, that one is perhaps a good candidate. As I said again, this is specific to the Oracle database, but perhaps another tool that you should consider under your belt for your applications. Yes, and you can see here we have some code samples as well that I can share the GitHub repo with you if you want after the session today. You can combine that as an example here with all the messaging related protocols. You can see IoT devices and apps, things like AMQP, gRPC, MQTT, Stump, you name them. Okay, so I have a quick demo here now just to show you how this API looks like. Okay, not this one. Yep. So I can, okay, if I can get a hold of. Okay, the first one is this RSI introduction here. Okay. The model here is just a simple publish-subscribe model. As Java developers, possibly you've used Java JMS, the Java Message Service, right? With publish-subscribe, and topics, or perhaps with queues and point-to-point messaging, right? But we have as published subscribers here and all the reactive strings libraries. The old model, if you prefer to refer to the traditional and classic design patterns, what we call the observer and the observable, right? This database is quite simple to use. Okay, you can see just a few imports here. The main component is the reactive strings ingestion component that I can call a builder, to get the object. So I just inform the traditional database connectivity details, URL, username, password, the target schema. And then I can just use the publishers, okay, to publish the records and have them added to the database. The push publisher is a kind of out-of-the-box publisher that you can get from this library. But for example, you can also use what we call third-party publisher. That's basically the use of the classic publishers provided by the JDK, for example, simple flow publishers. If you want to implement your own publisher, a customized one, it is flexible enough to support that. With this one here, I can just show you, for example, I can run this. I have a database table here where I can't see any, sorry, not this one. This one, you can see there's just 6 records inserted there. Okay, I can just run the push publisher, possibly. Where is it? Yeah, this one here, and then I will insert all the records at once and immediately. Okay, as I said, bypassing the traditional SQL mechanisms. So, yeah. If I come back here, you will see that they are all there now, okay? I have another sample related to this one here. This is just the intro. And by the way, for this one, I have, I have a blog post that you can perhaps visit to really understand, and if you want to reproduce that and see how that works, okay? Same thing with the previous example concerning virtual threads, okay? The example and the code sample is there for you, okay? So you can also execute and debug and really understand how you can use that with database connectivity. You can see the comparison of the number of OS kernel threads here as well for you. But coming back to the RSI example, the second one here, this is the intro, but I also have this with the autonomous transaction processing. This is a cloud-based database supported by Oracle. Okay, so you can see the Oracle Cloud Infrastructure here, and then I just created a simple database table here. If I select, you will see that actually it is zeroed here at the moment. I can just go and execute this example here. The nice thing with this one is that I combined RSI again with virtual threads. Okay, so I can get best of both worlds, right? A little bit of reactivity, but also the use of the RSI API. For this one here, I insert 150 records, so I can just run it here, and I will query the database later just to show you. Let's proceed here, because I really want to cover additional stuff here. Okay, so yes, talking about R2DBC now, as I said, reactive relational database connectivity. That's supported by other database providers and drivers, but Oracle has that as well. Perhaps another library that you should consider. This one, there is no dependency on the Oracle database specifically, okay, so because we developed it against the SPI, the service provider interface for R2DBC, of course, and then just implemented the specific constructions that will convey the functionality to work with the Oracle database, right? It runs on Java 11 plus, it is just a single jar that you can include. And the nice thing, this one you can use it and combine with, as I said, RxJava, Akka, Project Reactor, all the different reactive strings libraries, they are there for you as well, okay? And this one, again, there's no need to actually perhaps use, as the previous one, the direct path insert method, okay, as provided by the Oracle database. So all the different Oracle databases. Oracle, by the way, released recently what we call the developer database 23C developer release edition, which is a free database that you can download and install if you want to develop. R2DBC, you can see a comparison of both approaches here. The first one with traditional JDBC, just a simple query. You can see here a statement or prepared statement. You decide, right? You execute the query, you process the result set. And the second one, a combination of Flux, as provided by a Project Reactor with the R2DBC driver for the Oracle database, right? This is nice, another option that you should consider. The only thing, remember, is that somehow it might be difficult for you to debug this application, okay? So I have another code sample here just to show you how easy it is to use it. Yes, this R2DBC introduction. Okay, so let me perhaps do this. Yeah, you can see here, both Mono or Flux from Project Reactor. Okay, you can see the links here and a reference to Project Reactor 356 here, the latest release. Okay, so again, you just create a database connection as usual. And then you can run your queries, create statement, execute, and then you can, of course, this is a Fluent interface, apply all the operators, the reactive programming operators. If I execute this one here, perhaps I can do that in debug mode, just to make it evident that what I used as a statement, for example, when I proceed here, if everything goes well, of course, that's easy to do, but if I want to debug this thing here, you can see a single breakpoint for the entire call, and you can see the number of calls and operators and methods that I have here, so you understand it. It is not so easy to debug reactive libraries, right? I can just execute that with Mono and then with Flux, and then I just retrieve the IDs from the same database, and you can see the results here. So no tricks here. You should have a look anyway. All right, yes, so as a kind of discussion here as part of my talk, virtual threads are reactive strings, of course. As I said, Oracle database and the Oracle JDBC driver, we support both, right? Remember, the Oracle JDBC driver is available today for you, or you don't have to wait anymore. Possibly with the release in September, we'll have a new release as well, but the functionality is already there, fully tested for you, right? As it is happening with other projects, for example, Helidon with Nima, for example, there's a new server there for you related to virtual threads and so on. So many interesting projects that you should definitely have a look. Reactive. If you want to use reactive, we have R2DBC one, we have RSI, Reactive Strings Library, or the native, as I said, reactive extensions as part of the Oracle JDBC driver that are aligned with the JavaFlow API, A comparison now as a kind of wrap-up, okay? Benefits of virtual threads, easier to read and write, as we discussed today, easier to debug. Integration with the JDK's tools. Don't overlook that or underestimate this thing, because remember, the Java-based tools, they are all built in alignment with the Java threading model, okay? As I said, the flight recorder, JConsole, and a number of other tools here that are around, available around for you. They do consider that, so not so easy to debug reactive applications. And the most important thing, again, and I think we should always praise the guys who supported and worked hard to release virtual threads and Project Loom and everything, structured concurrency and so on. It does not alter the Java concurrency model. It is non-intrusive the way that they are doing it. The same API is there for you. They just augmented the API with some new methods, but the underlying implementation is really an impactful one, okay, because it changes everything, and the way that you can leverage the resources, it is undeniable. Limitations of virtual threads, of course. As I said, some libraries, they still don't support virtual threads, but we can see every day announcements and news about libraries doing that or moving towards releasing some VT compliant or compatible implementations. But most important thing here, it is still not in GA, okay, but about to be released in the scope of JDK 21. And you have the links for the related chapters here. First one, preview, second preview, and the proposal to finalize it in 21. Benefits of reactive, the availability of really powerful and perhaps useful reactive libraries, Reactor, RxJava, my favorite one, and so on. A string-like API functionality, so if you are doing streaming or eventing or those things, maybe at other different parts of your applications, or layers or components, you decide. maybe that's good for you, as an extension to make everything, end-to-end, use a reactive approach to the data access layer. Low-level concurrency is handled for you, but it is, as a limitation, hard to debug, harder to write, and there's a kind of steep learning curve as well. It is not so straightforward to learn it and understand the concepts, but something that you can master anyway, right? With the the effort that is required to do so. The references are here for you, okay, for virtual threads and Project Loom, an introduction, my blog post, from where you can get the explanation if you want to run that. The code sample is there for you, not only for the VT-related one, but all the reactive strings libraries with the JDBC driver are there, RSI, R2DBC. Our main landing page, where you can find, pointers to the Maven related pages for all the drivers, all the libraries, documentation, which is quite rich. You should have a look, definitely. Yes, I talked about the database 23C that got released recently. That's a free database that perhaps you can combine with the code samples if you want to run that and have a look, as I said. You can just go to oracle.com/23C free. And yes, and now I just want to talk about a couple of things here. First, Oracle Live Labs. These are our free workshops that are available for you. Okay, so we cover everything there. Java development with Halidon, Spring Boot, Java Message Service, Oracle Cloud, the database-related libraries, database development, machine learning, Python. Everything is there for you. So go and have a look. developer.oracle.com/live labs. And tomorrow, again, we'll have a workshop to explore Spring development for database access. So if you are interested in that, we'll be there to support you. And last but not least, Oracle ACE program. That's interesting, as I said. If you are contributing and an active community member, perhaps that's interesting for you, because Oracle has several different ways that they can support and recognize you as a distinguished member of the developer community and the Java community, of course, Java developers included. Some tiers here, the ACE Associate, Pro, and Director. That's nice because, it allows, I would say, a closer collaboration with Oracle, support to participate in some interesting efforts related to developments for things related to Java, but all things technology that Oracle is involved in, and also participation in events and so on, right? They can also invite you to participate in events, as a speaker. There are plenty of opportunities there for you. So I advise you to visit and have a look as well, ace.oracle.com/nominate. And nominate, of course, if you think that you have perhaps verifiable or strong contributions, I can nominate you. Just feel free to approach me. I'm a community guy. I'm a developer evangelist, so I'm always talking with developers, and I'm totally approachable, okay? Yes, and the last one, Oracle Cloud. There are some, as usual, some cloud services that you can use. They are always free ones, okay? So if you create an account, you can just run and get some services that you can use for free and test, and perhaps deploy some Java applications or do your POCs and pilots, or perhaps you have a side project. So don't forget to also visit the signup.cloud.oracle.com link to see if that's good for you. Last but not least, if you liked my presentation, this is my profile, okay, my Twitter handle. I have a blog on Medium as well. So as I said, you can feel free to approach me on Twitter, LinkedIn, or or here during the event. I'm more than happy to collaborate with you. And once again, it's a pleasure for me to be here today and participate. I came from Ireland to, to have this, I would say, great opportunity to present to you something that I'm passionate about, Java and also database development. Thank you very much.